Prakash?
Yes, sir.
Okay. Hello, ma'am. Welcome.
Hello. Hello, sir.
Yes. Meera, continue.
Yes. Okay, sir. Learning is like growing upstream. Not to advance is to drop back. Good afternoon, everyone. With great honor and respect, I would like to invite our speaker, Professor Sumitra S., to have a session on Introduction to Machine Learning and its application. Currently, Professor Sumitra is working as a faculty of Department of Mathematics, Indian Institute of Space Science and Technology. She has done an MSc in Mathematics and an MTech in Computer and Information Science from Cochin University of Science and Technology. She obtained her PhD in Machine Learning from University of Sheffield, UK. She has worked as a researcher for Center for Environmental Implication of Nanotechnology, University of California, Los Angeles, Terry Fox Laboratory, British Columbia Cancer Research Center, Vancouver, Canada, and UFR STAPS, University of Burgundy, Dijon, France. Her area of interest include theoretical framework development for machine learning algorithms and its application to real-world problems. Professor Sumitra has delivered lectures on artificial intelligence, machine learning, and various other topics at nearly 35 events. On behalf of Power and Energy Group NIT Calicut, I may request Sumitra ma'am to carry over the session. Over to you, ma'am.
Thank you for the introduction. Let me know how to share the slide.
Ma'am, at the bottom, you can see an option share.
Yeah.
There are two options, share and new whiteboard. Okay.
Yeah. Okay, so a very good afternoon to all of you. So you can see my slides, right?
Yes, ma'am. Yes, ma'am.
Okay, fine. So today I'll be talking about the introductory concepts of machine learning. So as you know, this is a webinar. I cannot see the audience. So, so I'm not sure whether you are following it. So if you have any doubts, please let me know. Okay, so let us start. So today I'm going to talk about the very introductory concepts about machine learning. So let me know if this is too basic or I'm going too slow or too fast or too advanced, whatever be. Okay, so let us start the talk. So first of all, what is machine learning, right? Or why do we need machine learning algorithms, right? So the programming task maybe can be divided into two. One is the traditional way of approach, and the other one is the machine learning approach. Now, what is traditional way of approach, right? So, if we want to add two matrices, you know, right, read A, read B, and sum those matrices. But that approach may not be used if you want to develop a software that could detect English alphabets. Or else if I want to develop a software that could detect corona patients by seeing its symptoms, I cannot adopt the approach which I have used for finding the sum of two matrices. So what should we have to do, right? So we have to look at the data right? So why we want to look at those data, whether data will be helpful. For example, if I want to teach a child some alphabets, one way is to write each letter on the board, right? So that when I write letter A, right, it can the child sees that letter, and when the next time when I write the next day when I write the letter C, even though the child doesn't know anything about C, the child can say that this is not what I have seen yesterday. Right, so can we adopt the same technique, right, to teach, to make the algorithm self-sufficient to differentiate between different alphabets? So, that is what we are going to do with the machine learning, a broad definition about machine learning area. So now let us look more into that. Okay, so this is mainly about teaching or developing, right, algorithms that are intelligent enough to do something. That is, I show the letter A to child. The next day, when I show the letter C, the child has given me the answer. This is not what I have seen yesterday. So the same thing we expected from the algorithms. The algorithm has to tell me this is not what I have seen yesterday, or this is what I have seen. So such types of replies we have to get from the algorithms. So basically what we do is we will give data to the algorithm, right? The data are some patterns which we'll see. Okay, so this is how we are going to teach or how we are going to develop very efficient algorithms, that is with the help of this data. Okay, so now let us look more deeply into that, right? So we are going to teach, or we are going to develop efficient algorithms. So the data is with us. So how we are going to give the data, depending upon that, this machine learning algorithms are divided into different techniques. For example, the first one is the supervised learning, right? So what is that meant by is that as there is a teacher who is there to teach, look, this is letter A, this is letter B. In the same way, if I want to develop an algorithm that could detect corona patients from non-corona patients, what we do is that we will collect some symptoms, right? As per the advice of the domain expert, we collect some symptoms from the subjects under study, and that symptoms we will give to the algorithm, and there should be some part which says to the algorithm, look, you are seeing now the corona patients data, or you are seeing now the normal subjects data. So that part we will put along with the data, right? So that information also we will give to the algorithm. That is, this is the corona patients data, this is non-corona patients data. That information, if we give with the algorithm, we will say that such types of algorithms come under the class of supervised learning. If there is someone to tell to the algorithm, some way to tell to the algorithm, this is belongs to this class, this belongs to this class. We will see how we will give that information. So if the data is using in that way, we will call it as supervised learning, right? Now, next is the unsupervised learning. Let us take this is the usual analogy I'm usually saying to all the talks. So, if we give some some toys to the child, right? For example, some fruit toys or some fruits to the child, right? Some oranges, apples, grapes, etc. Right? So even though the child doesn't know about those fruits, right? The child has the capacity to divide it into different categories, maybe by looking at its smell, maybe like looking at its shape, or using some way it will differentiate that into different categories, right? So in the same way, just by giving the data without any information about the data, right? For example, we will just give some blood cells to the data. right? Blood cells has some parts like lymphocytes, granules, such constituents in that one. So it has to understand what is what are the characteristics of one group in the way the child has understood that there are some characteristics for oranges, maybe the smell is the same, or maybe the color is the same, or maybe the shape is the same. For the grapes, they have some peculiarities as per the child's knowledge. In the same way, the algorithm has to understand the peculiarities of the data, and it has to differentiate that into different categories. If that is the algorithm is doing, we say that it is a unsupervised learning, right? Next is the reinforcement learning. Okay, this is a kind of supervised learning, but it is not the exact supervised learning. The algorithm has to understand the data from experience. For example, when the child first sees the fire, it has the tendency to touch the fire, right? So when it touches, the child understands it will feel pain. From that, it understands that this is not what something to play with, right? So from the experience, from the next time when it sees the fire, it won't go near it. So if we want to develop a robot or something like that, we will use this type of techniques, reinforcement techniques. It has to learn from experience, right? In the supervised learning, there is someone to tell, yeah, this is belongs to this data, this data. That is not there. The algorithm itself has to understand what is the difficulties involved in that data, and then on the basis of that, it has to take decisions, right? If we want to develop a software that could act to play chess and all, these type of reinforcement learning principles are used in those type of problems, right? Now next is the semi-supervised learning, right? That is a combination of some data we will have the information about the data. That information we call it as labels. So, okay, that is if for example, if the corona under study, for some data we know that it is coming from the corona patients. Some data we know that it is coming from the normal patients. For some data that is not there, whether it belongs to corona patients or whether it belongs to normal patients, that information is not there. So that are combinations of that data, and we have to extract something from that. That is coming under semi-supervised learning. So okay, so next is the there's the active learning. That is sometimes the information regarding the data is expensive to generate. Okay, for example, if you want to differentiate the web documents into different categories, like this document belongs to politics, this document belongs to sports, this document belongs to some other entertainments. So there are let there be millions of such documents are there, and we want to develop a software that could categorize this into that could understand by reading the document. It has to say that this belongs to sports category, this belongs to entertainment category, this belongs to politics. It has to understand, it has to tell me the answer. So for that, somebody has to first generate the data, and it has to tell is for the supervised learning. When we give the data, it has to tell the data, yes, this belongs to sports, this belongs to politics. But the data, such information generation is expensive, because some person has to actually go through that document and has to read it, and then has to say, yes, this is the document belonging to the sports, and then it has to put the data in like that. Yes, its label as the sports data, this label as, then it will give that data to the algorithm. But that label generation is sometimes very expensive, because a person has to go through millions of documents. So it is time consuming. Maybe it is not cost efficient. So we don't generate labels for each and every data, but we'll generate the labels for a small labels means the information, that is whether this is belongs to corona patients or not. That information we call it as the labels. We don't generate the labels for each and every data, but we'll generate the labels of only a subset of the data. Okay, so if that is doing, we call it as the using a small data will generate the labels, and then using that information we will decide which all data's labels has to be generated. Okay, so to decide that, we have to extract something from the data which the label has been generated. So that all coming under active learning. Now this transfer learning is, sometimes if you know one software language, it is easy to catch up with the others, right? So in the same way, that knowledge transfer is taking place. So such type of techniques adopting in this learning process, we call it as transfer learning. So this is a very broad description of different types of learning. So let us go a little bit detail into this. Okay, so seeing that we are going to first, we will be looking into this the supervised learning. Okay, so it is all about the data. Okay, so I have given the capital N data. Okay, with you. Capital N data means if we have selected 100 subjects for studying the corona data, this capital N stands for 100. So, okay, 100 subjects we have selected for collecting data. And from each data, let me collect 2 symptoms. For example, let me collect pressure and sugar level, for example. So there are 100 subjects under study, and for each subject I'm collecting 2 symptoms. Okay, 2 symptoms I'm collecting from each subject. Therefore, this capital N stands for 100, and each xi is now a vector because from each xi we are collecting 2 symptoms. Okay, so that belongs to raised to 2. So this is the the data looks like, right? So x1 will be a vector of length 2, blood pressure and sugar level, and we have collected such data from 100 patients. Now, what does this YI stands for? Okay, it's a supervised learning. So it is with the help of YI we are going to say that this belongs to this class and this belongs to this another class. For example, if it's a corona patient data, I will put Y1 as 1, and if it is not, I will put Y2 as 0. Okay, so this is how we'll be going to provide the data to the algorithm. Xi will be a vector. Along with that, Y1 will be 1 if that data comes from corona patient. Y2 is equals to otherwise Y1 will be Y1 will be 0. Or if Xi is a vector of length 2 and Yi will be 1 or 0. So okay, so this is how the data looks like. So this is the cardinality of the data set, and this symptoms we call it as attributes or features of the data. We have collected 2 attributes, therefore small n is equals to 2. Okay, fine. Okay, for example, we have collected data from 100 subjects. From each subject, let me collect the cholesterol level and fasting blood sugar. Then n is equals to 100 and small n is equals to 2. This is an example. Okay, so this is how we are going to represent the data. So from each patient or from each subject or from each data, we are gathering some characteristics, right? So each data is a vector. Vector we will always represent in a column format, right? So this is xi1, this is xi2, right? For this example, xi1 stands for that person's cholesterol level, and xi2 stands for that person's fasting blood sugar level, and it will be of length 2. Okay, so it will always be represent this column format. So this is the transpose. Okay, so now let us look more into this one. I have shown you some data too. Okay, this is 3. This is X part. It is only a real number, and I have shown its output. This is the Y part. Okay, this is 3, and this is 9. So this is 4. This is 12. This is 5. This is 50. Okay, so this is the data. Now I'm going to ask you what is Y. It is easy for you because you have understood the relation. Moreover, you know what is multiplication, right? Then only a person with who knowing multiplication can answer this question. As you know multiplication, this is very easy for you. You will say that the answer is 18 because you have understood the relation between this part and this part. Okay, right? And only 3. This is a very easy question. Now we'll come to the next one. So, okay, as I said that we always write this data in the column format. That's why I've written this transpose. So in the place of 3, now a vector is coming, right? And a vector of length 3. And this output is 1. And another vector output is -1. So from a real number, we are now going to vectors, right? So now I have given you can you say what is Y? I don't know whether there is a pattern in that. If it is a pattern, can you say what is Y? Now you may be finding difficulty, right? It is not easy as this one. Okay, we have only 2 data, and the length of from each data we have there is only vector 3. Still, you are finding difficulty, right? So now you can imagine, okay, a very huge database with millions and millions of data. This millions of data, that stands for the cardinality. Here the cardinality is 3. So millions of data is the cardinality. And for each data is a height dimension. This is 3 dimension. This is 1 dimension and its output. This is 3 dimension and its output. So, you know, how difficult to extract information from a very huge database with millions and millions of data. And each data is high dimension. Right? So now you can appreciate the beauty of the automated algorithms that can be capable to extract information from the data. So if we give all the data from the corona patients and the non-corona patients, definitely if there is a pattern only, we can extract it. Definitely there will be a pattern. And if the algorithm is clever enough, like we have clever enough to understand the patterns, in the same way, if the algorithm is clever enough to understand the underlying patterns of the data, then what happens? If I just give the symptoms of a subject, if it is clever enough, right, to understand the patterns, if I just give the symptoms, as we just give the symptoms, it would be able to generate the output as we have generated the output here, right? 6 3 is 18. That is what is going to happen. Okay, so this is it has to understand the patterns like we have understood the patterns here, and this why if we succeed in understanding that patterns, given a new data, we would be able to generate the output correctly. So that is what we are going to do. Giving a data, trying to understand the patterns so that given a new data, we would be able to find the output. And you know that how difficult it would become when there are millions. It is impossible for the humans to do that. So we need some automated tools to extract from that data, and that is the significance of this machine learning, importance of this machine learning algorithms. Okay. So that is what I said, that this is the training data. Here, this stands for the training data. This stands for the training data. This is from this, it has to understand the patterns. So that is what we have a training data. Okay, so after the training data, after understanding the patterns, we will give the test data. And that what will you do? If for this one, it has to give me the answer. Right. So this is what is going to happen. So now we are going to look in more into this to the supervised learning. So okay, now this supervised learning, it is divided broadly into two. So okay, one is the classification and the other one is the regression. So okay, as I said that this supervised learning, the data will be of this form. So this we call it as the label, and this is the attribute data and corresponding labels, right? So how this, depending upon the labels, we divide the approach into two. So right, these labels can be either discrete of some finite, coming from a finite set, or it's not countable. So okay, it will be two things can happen, right? One is countable, otherwise not countable. So depending on that way, we divide this approaches into two: classification, and the other one is regression. So okay, for example, if the labels is called the Y, takes only two different, each Y takes either 0 or 1. So it takes only two different values. We call it as a binary classification problems. Or else if it is taking three other, sometimes the Y is allowed to take either -1 or 0 or 1. We call it as a 3-class problem. Okay. So otherwise it's a multi-class problem. So 3-class or one is binary, otherwise it's multi-class greater than 2. This is okay. So depending upon how many different values it can take, this will be a finite set. We will, if it can take k different values, we call it as a k multi-class problem. So okay, the k class problem. So okay, otherwise the output are continuous. That is, if Y can take, for example, if Y is allowed to take any number between 0 and 1, right? So it's not countable. We cannot count the numbers between this one. So if that is there, we call it as a regression. Or Y can be take any real number. So in that way, the problem becomes regression. So there are two things, depending upon the label, this Y part. If it is discrete, we call it as classification. So other we call it as regression. Okay. For example, this is a classification data, because we are, for example, we are studying the arthritis data, and we have collect the electromyographic patterns from each subject under study from leg muscles. These are 2 leg muscles. And I'm calling, therefore there are 5 data sets are there. So this is the number belonging, which I call it as x11 and x12. It can take some number. Okay, we are not worried for the time being what is that number. So generally I put it as x1 and x12. And here you know that this Y takes either 1 or 0. So we call this as a classification problem, because it is coming from a finite set. Either it can take 1 or 0. So if this is how we are going to give the data to the algorithm. So when this data is belonging to the arthritis patient, this is not. So there is some information is there to say something about this data. This is that information. So, okay, so this is how the data looks like for supervised learning. So as this is an introductory talk only, I'm explaining all these concepts. I'm not sure whether everybody knows it or not. If it is too basic, let me know. Okay. Now there are, if it is a 2-class classification problem, that is, what is 2-class classification problem? It is Y can take, that is label can take 2 different values, right? either 1 or 0, minus 1, 1, how we are putting that numbers, but it is allowed to take the labels, the set consisting of labels that cardinality is 2. So, okay, so the y can take only either 1 or 0, 1 or minus 1, whatever be, but it is allowed to take only two. The labels are coming from a set of cardinality 2. So, okay, so in that case, we call one as the positive class and the other as the negative class. For example, here it is allowed to take either 1 or 0. So we will call the set of all data belonging whose label is 1, we call it as positive class. The label as 0, we call it as the negative class. So just a terminology. We'll call, you can call the data with either 1 or 0 as positive, the other one as negative. So now we'll coming to a regression data, right? Here, if it is, for example, if it is angular position and velocity, these are just numbers, okay? So this is the angular acceleration. As you know, angular acceleration can take any real number. So this is not a classification problem. This is a regression problem. So if the algorithm understands, right, if it is succeeded to understand the patterns, that is, if 1 and 3, if its output is 1, if it succeed to find the relation between these two, then given in angular as position and velocity, if it succeed, it could give me the answer about its angular acceleration. So that is the objective. So this is how the data looks like. So, but this is not what we have seen before, because it can take any real number. Okay. So now, this is what. So this capital X and this capital Y. Okay. So right, this is the output that labels. For example, this is capital Y and this is coming from capital X. Here we can take the capital X as R2. So, okay, so because each xi is coming from R2 and its label is coming from R. So, okay, so what is learning means we are going to find a function or the relation between this x and y. That is what we are going to do. For example, that the first example, right? We have understood that f of x is equals to 3x. The first data which I've seen you, which I have shown you, the relation is f of x is equals to 3x. So such a relationship, right, for this one, f of x is equals to 3x. So such a relationship, that is what the algorithm has to extract from the data. So that is what is learning. It has to find the function. Okay, so this is its domain x, this is the domain, and the range means the set of all y, the set of images is called the range. It's okay, right? This is, if this is the case, we call the y is the image of x and x is the pre-image of y, and 1 to 1 and on to. Okay. So if 1 to 1 means, right, maybe you know all these concepts, right? So this is what we are interested to find the relationship between x and y. That is what we are going to do this machine learning algorithms do with this data, right? Okay, so now we will go into more into this. Okay, so first is we have seen this binary classification problem, classification and regression. So now we'll look more into that. So, okay, so this is the data of a we'll go concentrating on classification. Okay. So this is a two-class problem. Two-class problem means that labels Y can take only two different values. So, so this is the data belonging to one class, and this is the data belonging to the another class. So here it can be, this data can be separated by a line, right? So, so in classification, what we are in, this is called the decision boundary. So if you succeed in finding the equations of this line, then we can call this as f of x is equals to 0. And if you know the form of this f of x, then given a new data, if f of x is greater than or equals to 0, we put it in positive class. And f of x is less than 0, we put it in the another class. But we should know we should find the exact formula or equation for this line, right? But you can see the another one, right? Same data, but there are number of lines actually that divides these two classes, right? So which is the best one? For example, if one person choose this as the best one, then given and another person choose this as the best one, then given a new data, it's for as per this person, let's call this blue as positive class and red as the negative class. So as per this line, if I select a point here, as per this line, that point belongs to the positive class. But as this line, it belongs to this side, it belongs to the negative class, right? So as you can see that there are many lines that divides this into two. So from this, we have to select the best one. So that is a challenging part of this one, right? Okay, so this is a case of the line that divides this into two. So now, how we plot this data? For example, if the corona for this data, right? This is Soleus and Gattonius, this one. So we will plot one here and another value here. And for each data, there is it is a vector of length 2. We will plot this data. That is how this data is plotted. Okay. So if we have, these are called the attributes, right? This has two attributes. This has also two attributes. So here, two attributes, right? Attribute is what we have seen, that the characteristics which we have collecting from each data, right? If we collect blood pressure and sugar level, from each data we have collected two symptoms, right? So it can be plotted one attribute here and another attribute here, and we can, this is how it is plotted. Now, if it has more than two, right? For example, this is three attribute is plotted. Now, this is the called the decision boundary. This is now becomes a plane. So if it has four attributes, in general, we call it as a hyperplane. So, okay. So this is a hyperplane. So okay, either it is a line if it has two attributes. If it's a plane, it's three attributes. If it has more than three, in general, we call it as the hyperplane. So if we succeed to find the equation of this hyperplane, then we can say that in which class the data belongs. So that is about here the decision boundary is hyperplane. Now the question is, does all the decision boundaries always a hyperplane? So that is the next question. So for example, we will consider the datas here. So actually these two datas belongs to the same class and these two datas belongs to the different class. But as you can see that this cannot be separated by a line, Am I right? We cannot separate this blue data together as on one portion of the line and the two orange data another portion of this one. With the help of a line, this cannot be separated. So we will go for the decision boundary which is not a hyperplane. So two types of decision boundaries are there. One is hyperplane and the other one is not a hyperplane. So if it is a hyperplane, we call it as a linear algorithm, and the data we call it as separable because we can separate by a hyperplane. Otherwise, we call it as a non-separable data and we'll go for the non-linear algorithms. Now we'll take the case of regression. Okay, take the case of regression. So in the classification and regression, we're looking into the difference between classification and regression. In the classification, we divide the data into different categories. What is happening in regression? In regression, it is not dividing. Then here X, here Y. Okay, so X is okay. So X and the given output Y. Okay, so here it is the data and here it is its output, right? So, and we are interested to find a function that approximates the given data. So if you succeed to find such an equation, given any data, you can find its corresponding output. So that is not what is happening in classification. And also you can see that here there are three attributes are there, right? Here there are two attributes are there and the decision boundary is a line. Now let us come to here. Here actually the data does not have two attributes because this is data and this is its output. The data has only one attribute and this part is its output only. Okay, so that is in the classification. Here we plot one attribute and here we plot another attribute when the decision boundary is a line. Here the same for regression. Here the function that passes through the point is a line, but this part corresponds to its output, not the attribute, right? This part is the data and this is its corresponding output, and we will find the best line that passes through this data, so that given any data we can find the corresponding output. So in the same way, if the data has more than one attribute, hope you understood what you mean by attribute, right? From each data we are collecting some characteristics. So for example, we collected 3 attributes, right? So one is a fasting sugar, one is blood pressure, and another one is the temperature, body temperature. So we have collected 3 attributes. So, okay, so we are considering of regression. So if the regression first is the line we have seen, now here we have collected the data has 2 attributes and the third coordinate is its output. So okay, so for this one is a plane. So if the function that passes through the data is a plane, the data should have 2 attributes and the third attribute is its output. In the case of regression, same thing for the case of classification, 3 attributes and the decision boundary is a hyperplane, But in the case of regression, two attributes and the third coordinate corresponds to its output, not the attribute. For regression. For classification, if the decision boundary is a hyperplane, if the decision boundary is a plane, it's all its coordinates correspond to its attributes. Here it is not that. It is a plane, so two coordinates correspond to its attributes and the third coordinate correspond to its output. Okay, for example, angular acceleration, this example, what we have seen, angular position and velocity. So two attributes, and this is its output, angular acceleration. So if it can be, if the function that passes through this data is a plane, one axis corresponds to angular acceleration and the other axis corresponds to velocity and the third coordinate corresponds to its output. Now, for this one, one coordinate corresponds to this attribute, another coordinate corresponds to this attribute. So we can plot this in 2-dimension itself, and we will find the decision boundary. Here, same, but for this one you need 3 coordinates. Okay, one coordinate is angular acceleration and the other coordinate is velocity and the third coordinate will correspond to the output. But for classification, if it is only 2 attributes are there, we can plot it in 2-dimension. Okay, so in the regression also, we are interested in the function that passes through the given data. So the function that passes through the given data can be line, as we have seen here, or can be a plane, or if it has, to this one, it has 2 attributes. If it has more than 2 attributes, the name is hyperplane, right? So for the regression, the function passes through the data points can be a hyperplane. If it is not a hyperplane, we call it as some nonlinear data. If that is the case, we call it as we have to use nonlinear algorithms. So if we know that the function that passes through the data is a hyperplane, we'll use linear class of algorithms. Otherwise, we have to use a nonlinear class of algorithms. In the same way, for classification, if the data that divides the data can be a hyperplane or not a hyperplane. For regression, the function that passes through the data can be a hyperplane or not a hyperplane. So the question is, if the decision boundary is a line, how many attributes the data has, right? How many attributes? It will have 2 attributes. If for regression, if the function that approximates the data is a line, how many attributes the data has? Only 1 attribute, because the other one is its output. So, okay. So if it is a hyperplane, we use linear algorithms. Otherwise, we will use nonlinear algorithms. Okay. So now let us look how the data is generated. So okay, let us see an example of this data generation. Okay. So for example, we'll take an example of taking a ball from an urn 3 times. So, okay. So let the ball consists of 6 blue and 4 orange balls. So that is the one. That is an urn consists of 10 balls, of which 6 are blue and 4 are orange. Okay. So, and what is that? If we are getting blue ball, we call A1 as 1 or AI as 1. Otherwise, we call AI as 2. If it is a blue ball, we call it as we'll put AIS1, otherwise we'll put AIS2. So the first day, 3 times we are taking the balls. So only after the ball has taken 3 times, the experiment is said to be completed. So 3 balls have been taken. Now we'll go to the initial setup and then again. So the same experiment is repeated 3 times, and each experiment consists of drawing a ball. So that is what? Taking a ball from an urn 3 times. So the same experiment is repeated 3 times. So after this one, we have to go to the initial setup and then we have to take one by one ball each. So if I get the first one, it says an orange ball. Okay, so here it is written for the blue ball it is 2, and for this otherwise it is putting 1. So, okay, so that is how it is written. So if, as it is an orange ball, I put 1, and for this blue ball it is written 2, 2. For the blue ball it is written 2. Otherwise it is written some mistake is there. Okay, so it is BBO. So it is 2, 1, 2. Here 2 stands for the blue ball and 1 stands for the orange ball. This is actually O. So this is 2, 2, 1, 2, 1, 2. So okay, so how we are generating the data is, this is X1 is 1, 2, 2. There are 3 attributes are there. This is 2, 2, 1. This is X3 is 2, 1, 2. This is just to show with an example what do you mean by this data generation, right? So this has 3 attributes are there. This one corresponds. So to generate one data, this corresponds to one data. To generate the second data, we again go to the initial setup and then we will generate this data. Okay, so for each data generation, we will go to the initial setup and then this BBO is generated. So that is how this data is generated. So we have got 3 data, and for each data we have 3 attributes are there. That's right. For the second day, I have got like this OOB. But here you can see that X1 is different from this X1. X2 is different from X2. X3 is different from this one. That means each time, if I'm interested to take 3, these are called the samples. X1, X2, X3 are the samples, right? So if we take 3 samples from this population, that 3 samples will have different values each time, right? So these X1, X2, X3, here also they are X1, X2, X3. As you can see that they are taking different values. So we can call these data as random variables because it is not definite. Its value changes. For the first day I got this value, for the second day I got this value. So these X1, X2, X3, we can call it as the random variables. And also this attribute, right? For the first data, this one is 1. For the second data, this is 2. So this attribute also we can consider it as a random variable. So each data point we can consider it as random variables, and each attribute, this is A1, A2, A3, they can also be considered as the as a random variables. For example, this is just to say about a terminology called independent and identically distributed data. For example, we are experiment with replacement. So okay, that means I'm taking first a ball, then I'm replacing it back, and then again I'm taking it one ball, and then again replacing it back, then again taking one ball. So, okay, that is how this data. Then we'll go into the initial condition, and then we are generating this one, that is taking one ball, keeping it back, then taking one ball. So if it is experiment with replacement, here we can see that definitely as each time we are going back to the initial condition, these xi's are all independent because after this this one will go back to the initial condition, and then only these are generating. So they are not depending. So we can write it as P of x1, P of x2, P of x3. And for also P of x1, x1 consists of actually, it is a random vector because it consists of 3 random variables. But here, as we are choosing with replacement, they are also independent. That is, when we first ball will choose, and as we are replacing it back, the number of balls is always constant. So these attributes are also independent. So if I write P of x1, x1 is actually 1, 2, 2. That also I can write it as P of A1 into P of A2 into P of A3. So samples are identically distributed and they are independent. The attributes are also independent. Okay. Now, if I'm taking experiment without replacement, without replacement means if I take the first ball and then I'm not putting it back. Putting it back means after taking the first ball, the number of balls will get reduced by 1. So the probability will get changes from each time. The taking a blue ball or orange ball, the probability changes. So there is a dependency between the attributes. But so first I take the orange ball and then I am not keeping it back. Then I'm taking the blue ball. So the number of orange balls gets decreased by 1, and also the total number of also balls will get decreased by 1. So there is a dependency between the attributes. But after this point, again we go back with the 10 balls we are starting. So only there is a dependency between the attributes, but there is no dependency between the samples. Right? Because after this, we are again going to the initial condition and then only we are drawing 3 balls. So there is a dependency between, because as we are not keeping it back, there is a dependency between the attributes, but there is no dependency between the data sets because after this we are going to the initial condition, that is with the ball with the 10 balls, and then we have to repeat the experiments. So experiment without replacement, for that still you can write it as P of x1, P of x2, but P of x3, but this won't become P of a1 because the attributes will become dependent because we are not keeping it back. So this x1, x2, x3 are the samples. Samples are independent, but the attributes for this case are dependent. So in the machine learning algorithms, it is assumed, always assumed, that this data points or the samples are like this. Okay, samples are independent, right? After getting 1x1, we are again going back to the initial setup and then only we are taking the x2. So there is no relationship between x1 and x2. So that is what it is, independent and identically distributed. The algorithms are independent and identically distributed, right? If it is not keeping it back, right? So the first probability to getting an orange ball is, right, it is 4 by 10. But if it is not keeping back, then the getting a blue ball is 6 by 9, not 6 by 10. So so that why it is not becoming this. But still this is true, P of x1, because after this one we are again going to the initial condition to generate the after this one again the box is filled with 10 balls and then we are conducting the experiment. So this data points are independent. For this case, this attributes are dependent. So in the machine learning algorithms, it is always assumed the data points are independent. The attributes may or may not be independent, that we are not worried about, but this is always there. So okay, after generating one data, we are going back to the initial condition and then only picking the next data we're collecting. So that is, it is assumed that the data points are independent and identically distributed. Okay. So now we'll go more into this machine learning algorithms. So first is we will look into a regression tasks. Okay, so we have seen the classification, we have seen the regression. So we'll first talk into the regression tasks. Okay, now, and for the regression, I've seen that we are interested a function that passes through the regression, we are interested to find a function that passes through the data points. Okay, so the function that passes through the data point can be a hyperplane or not a hyperplane. Here we are looking at the case where the approximating function is a hyperplane. Okay, so this is a regression task, and the function, that is, we are taking the case of a linear algorithm. So first of all, given the data, we don't know whether we can apply linear or not. Nothing we'll be doing. So we first, let us assume that and it is a linear, and if you are getting bad results, then we'll go to different approach. So okay, so first we'll take the case of a regression task, and the function that passes through the points is it's like a hyperplane. So if this is the case, how we will do it? You're familiar with the inner product, right? Or dot product. So general name is inner product. If the two vectors are there, we'll give the notation. So okay, this is the dot product, as we call it as the inner product. This is A transpose B. So this is the notation going to give for this to represent this inner product. Now let us look into the equation of a hyperplane, right? So the equation of a line passing through the point is this one, right? Y is equal to mx plus c. So actually this is a regression. So this stands for its output. Okay, that is so mx plus c. I'm taking this to this side. So I'm writing using a different notation. This is the bias. I'm putting it as W0 plus W1x plus W2y is equals to 0. So this way I'm writing it. So now for the equation of a hyperplane passing through the point xi, yi, this xi, yi is in R2. So I'm taking it as r raised to n plus 1. This is the output. Output belongs to and r raised to n, and one more thing, why we are adding one more coordinate, its output. Then we write it as yis, right, like the same as mx plus c, right, we are writing it as w0, that is w0 plus mx in the place of w1. Its coordinate is first coordinate. This is the attributes. It has n attributes, xi1 into w2 xi2 to n1. This is just the generalization of this one, right? And we are writing it in this way. So again, this way for regression, we'll write it in this way. Output is equals to this one. So we can write this as W0 plus W1 xi1 plus W2 xi2. This is the equation of hyperplane, right? That passing through xi, yi. So this we can write it in terms of this inner product, right? Like this A transpose B. We can write it as this W0, W1. We can write this, if we take the vector, this as this W as W1, W2 to Wn, then I can write this as W transpose, right, Xi plus W0 is equals to 0. This is the inner product between this one and this one, right? W1 into xy1 plus W2 into xi2. So I can write this as W transpose Xi plus W0 is equals to 0. Okay, so this is the equation of a hyperplane. So what we do is we will be giving this data, right? And this each xi is a data. It belongs to r raised to n, means from each data we have collected two attributes, right? Like position and velocity, like that we have collected two characteristics from each data, and yi is in this one, right? So we will write this input. This is only given to you, so we will assume that this input relationship is in the form of a hyperplane, right? F of xi, this is the equation of this bias plus w1 into first attribute plus w2 into xi is xi1 xi2 to xin. That is how we denote it. So f of xi, we can write this as this one, w transpose xi, by putting, we by appending 1 to this xi and writing w0 as this one. We can write this f of xi w transpose xi. So what is we are interested is to find the unknowns. Okay, so this may be you may be familiar with, right? Very much familiar with. So I'm just introducing a very basic algorithm. Uh, so uh, we are assuming that the relationship, the function that passing is a hyperplane. So we write this equation, and as this is our assumption, we put that as our assumption as f of xi. So this is the output generated by the model which we assumed. Okay, though we call it as the predicted output. This is the given output. So this it's the relationship is in the form of a hyperplane. This is the equation of a hyperplane. So this is how we write it as. So now what we want to find is if we want to get what is W0, what is W1, what is W22, what is Wn, then our job is over. If we succeeded in finding the best one, then given any x1, we can find its output, right? So how we will find this W0, W1 to Wn, that is the question. So how to choose this one, right? This is our prediction. We predict that the relationship between the x is this one, f of x1, f of x2 to f of xn. There are capital N points are there, and the output, the given output is y1, y2 to y capital N. So this is the prediction vector and this output. Now, how do we find the w's, right? So what we do is, one way to find the w is find that w, this each f of xi is w transpose xi. So find that w's which minimizes the distance between these two vectors. This is the given vector and this is the prediction at each point, right? So find that w which minimizes the distance between these two vectors. So we will find, how do you find the distance between these two vectors? It's a Euclidean distance is f of xi minus yi the whole squared. So this is the distance between, this is the prediction and this is the given one. So find that w which minimizes the distance between the prediction vector and the given output point. So this is called the least square cost function, and we will find that w star which minimizes this distance. One question is, all these are known to you? Is it too basic? Can you hear me?
Yes, ma'am, you are audible, ma'am.
Okay, audible. Is it too basic?
No, ma'am, no, ma'am. So far, so good, ma'am. It is really good, actually.
Okay, fine. Okay, fine. Okay, so just to know that whether, okay, fine. So what is this? This is a prediction vector and this is the given output vector. So what we do is we find that w which minimizes the distance between the prediction vector and the output vector. So what we do is, this is the Euclidean distance, right? Euclidean distance is f of xi minus yi the whole square, right? So we call this jw as the least square cost function. Okay, we call this as the least square cost function. And what we do is, we find this each f of xi is actually this, right? This w transpose xi. This is the bias, and we append 1 to this one, and we write this in a compact form. Okay, w transpose xi. So this w is there. So how do we find the w? The one, this is, we assume that its relation is in the hyperplane. So we find that w which minimizes the distance between the prediction vector and the output vector. So how do we write that in a mathematical form? Find that one. This argument means find that w. You first find the minimum of one, then pick that w which minimizes this one, right? So we we have to find the minimum of JW. That is what's argument minimum. Find that W which minimizes the JW. That is how what we have written. Okay, so that is the optimal one as per the data. That is the optimal one. So okay, now how do we are going to solve this? This is a optimization problem, right? Finding the minimum or maximum of a function is called a optimization problem, and this is a unconstrained optimization problem because we are not putting any constraints from about W. W is a vector of length and small n plus 1, so it can be any W on that R raised to n plus 1. We are not putting any constraints there. So this is a unconstrained minimization problem. Okay, right? So well, how does this look like, right? This is actually in the form of y is equals to x squared, or JW is the square of this term. Okay, so so what we, it is in the form of it is a form of a parabola. It's okay. So to solve this one, we are going to use a iterative algorithm. Okay. So I want to find the minimum of this one. I'm going to use a iterative algorithm, right? So if we plot like this, actually the minimum happens here. So in the iterative algorithm, what we do is we first guess a initial solution, and then we some way we have to move to this W, right? So from this we have to, this is called the tangent or the gradient vector, right? So what is the direction of the gradient vector? From here the function increases this way, right? Here the function decreases. So the direction of the gradient vector is the direction where the function increases. So the increases in this way. So the direction we'll take it in this. So this is the positive and this is the negative. It's okay. So now the direction in which the function increases. So this is the direction of the vector, tangent vector or gradient vector, because the function increases in this form. So okay. So if it is in bulging form, the function in, so we have to look at in that way, and we have to plot the, for example, if it is here, the function increases in this way, right? So here the function increase, so it is the direction of the gradient vector is in this way. So now how we are going to solve this one? We are going to use, this is a minimization problem, and I'm going to use an iterative algorithm called gradient descent. Okay, gradient, it makes use of this gradient vector. So as it is a minimization problem, we use gradient descent. If it is a maximization problem, we use gradient ascent. Okay, so if it is more than, right, here if it here W, right, and this here's JW, right, 2 axes are there. If there is more than 2 axes, we'll get a shape like this. So now how we are going to do, right? So the function increases in this way. So the gradient will tell you, the direction of the gradient will tell you how the, to which direction the function increases. So what we have to do, we have to move, this is the direction of the direction in which the function increases, and the direction of the gradient is the same. So move negative, that is the direction opposite to the direction where the function decreases, or take the negative of the gradient at this point, right? So that means you have to go through this way. So okay, so what we do, so what, how this is happening is, we find an initial weight here, and we have to find the gradient's direction and the direction of the, where the function increases are the same. Move in the direction opposite to that. So how do we write it? So we our search space is R raised to n plus 1. Why it is R raised to n plus 1? because there are n+1 unknowns are there. One is bias, and this is the weight corresponding to each attribute. Okay, so we take one W, right? And how do we update that W? Okay, from that one, move in the direction opposite to the gradient at that point, right? So move in the direction opposite to the gradient at that point. And there is something called alpha, right? That is how much steps we have to move. So, okay, that is deciding by this alpha. We don't have to go through this part, right? We don't have to, right, from a big jump. So this alpha will, there is one parameter, this alpha. This is called the learning or step learning parameter, or this is called the left step length. So I'm putting it as this is the current value, and this is the new value. This new value becomes the current value minus right. This is the from this W, and we have to go this way. Okay, so how do we go to this W? We have to go then to this W. Each time it is updating, and then we're reaching the minimum. So this is how alpha W is equal to alpha minus the gradient at that point, right? So this is J is a function of W1, W2 to Wn. Now, how do we find this gradient is a vector, right? As W is a vector, gradient with respect to W, how do we find it as? It is dou J by dou W0, dou J by dou W1 to dou J by dou Wn, or this W0, this is the current new value, and this is the current value, minus alpha into dou J by dou W0, dou J by dou W1 to dou J by dou Wn, and there is one alpha, right? So that decides the step length. It's okay. So this is how we are going to find the minimum of the function. Now, how to find the gradient of J, right? Here J is this one. I put 1/2 here because finding the minimum of JW and finding the minimum of K into JW, there won't be any change. For example, the minimum of x plus 1 the whole squared, the minimum of x plus 1 the whole squared. How do you find? You will take the x is a real number. So how do you find? You will take the derivative 2 into x plus 1 and you will equate to 0. And you will get the 2 into x plus 1 is equals to 0. So you'll get the value x is equals to -1, right? So if I find the minimum of 5 into x plus 1 the whole squared, still I will get the minimum as x is equals to -1. There is no change if we take the minimum by multiplying a scalar to this JW. The minimum of JW won't get affected. Now, finding the minimum of, this is how we have taken the JW. I just put a scalar here that won't affect its minimum, right? For example, the example I've shown you, the minimum of x plus 1 the whole squared is same as the minimum of 100 into x plus 1 the whole square. There won't be any change, right? You can check it, right? So why we are putting it as a half is for computation purpose, for ease of computation. So this is JW, and f of xi is actually this hyperplane equation, W transpose xi minus yi the whole square. Now, how do I take the gradient? Gradient is equals to 2 into 2, so that 2 get cancelled. That is why I have put that half, and it won't make any change in the minimum. 2 into W transpose xi minus yi. It's not get finished. Now we want to find the gradient of dou by actually this is not dou by dou xi, actually sorry, this is a dou by dou w. We want to find the gradient with respect to w. So, okay, so this is dou by dou w of w transpose xi. So here's the gradient with respect to w. So this is dou by dou w of w transpose xi. Okay, so this is not xi, this is dou by dou w of w transpose xi. And how do you find the dou by dou w? Sorry, this is not xi, this is w. So okay, we are taking the gradient with respect to w. So that for that we have to use this result. Dou by dou a of a transpose b is b. Okay, dou by dou a of a transpose b is b. Dou by dou b of a transpose b is a. Okay, dou by dou a of a transpose b is b. In the same way, dou by dou w of w transpose xi is xi. Here in the place of w it is a. Here in the place of xi it is b. Dou by dou w of w transpose xi is xi. Okay, so this is how we take the gradient. So this is so how this equation becomes, the new point is the current point minus alpha into alpha in we have taken the this is how this is a minimization. We'll move in the negative direction, negative of minus alpha into w transpose xi minus yi into xi. Take the minus sign outside, so it will become w is equals to w plus alpha into sigma is equal to 1 to capital N yi minus w transpose xi into xi. So okay, so this is how we have to find the minimization. We have to move the direction negative of the gradient, right? Find the minimum of x plus 1 the whole squared. There x is the variable, we take the derivative with respect to x. To find the, here w is the variable, so we'll take the derivative with gradient with respect to w. And so when we substitute here, we get answer is the new point is w minus alpha, gradient is sigma is equal to 1 to n, w transpose xi minus xi. Take the minus sign outside, so it will become w is equals to w plus alpha, sigma is equal to 1 to n, yi minus w transpose xi into xi. So this is how we will update. So this is how we are going to use the gradient descent. Initialize w. So okay, then iterate until converges. That is, we find some randomly, we'll choose some w. Then iterate until convergence. W is equals to w plus alpha, sigma is equal to 1 to n, yi minus f of xi into xi. This is the algorithm. Now this I've written in a vector. Each component wise I can write wj as wj by putting j is equals to 0, 1 to n. So okay, so each component wise I can write it as, okay. Now this is how, that is how the linear regression works. Now what is the stopping criteria? Iterate until convergence means when the difference between the current value and the new value, there is no change, we will stop it. That is what I will put in norm, right? Distance between x and y is same as the norm of x minus y, right? So that is w new minus w current. When there is no change, we will stop the algorithm, right? So now what is the drawback of this is, it consists, there is a sigma I is equal to 1 to capital N is coming. So what we do is we will go to the stochastic gradient descent. Okay, that is it is instead of taking this capital N data, it will take one data at a time. That is first, it will first assume that we have only one data in hand. With that data, update W. Then what will we do? Then take the second data and take the W what you have got as the current value and then update W again using the second data. So if there is only one data, when we starting, we assume that we have only one data in hand. So what we W plus alpha into, for example, only x1, y1 in hand, we'll update as y1 minus f of x1 into x1. Then using that W as the initial W, we will take the second point x2 and then update W. Okay, then take the third point and again update W like that, capital N point, and take update W. After we have completed that entire loop, then again come back to x1 so that we can get rid of this sigma is equal to 1 to capital N. So this online version of gradient descent is called the stochastic gradient descent. So it processes only one training point at each step. So how do we do is that choose an initial parameter and the learning parameter alpha, same as iterate until converges. Instead of sigma sign, we put it as like this, a for loop. For I is equal to 1 to n. Okay, so using the first data, update W, and then go back and take the second data, update W, and like that, continue till capital N, and then look whether there is, whether it has converged or not. If it is not converging, we will continue the iteration. So, okay, so there is a learning parameter alpha. This is not a parameter. This is called the hyperparameter, which we have to fix before starting the algorithm. Algorithm finds these parameters, and this is called the hyperparameter, which we have to fix it before doing the experiment. So the parameters, the user has to fix it before doing this for the algorithm to run. Such parameters are called the hyperparameters. So this is also we will, as a vector, we'll write it as a component. Okay, so now after finding this W, we got the model. Then we have to check the performance of the model, right? Because you will be given only some data in your hand, and we don't know whether the points approximating the algorithm is a hyperplane or not. We don't know whether we can apply linear regression or not. First we try with linear regression, and we found the best optimal W. Now you have to check how good the whether it is the hyperplane that approximates the data, whether our assumption is correct or not, or should I have to use another algorithm, right? So for that we test it. For that we will choose some points, and you have already know the values of W's. So for each xt1 you can find f of xt1, because we have already found each f of xt1. F of xt1 is W transpose xt1. We have already found a W. Using that one, you can find f of xt1. And then you will take the difference, right? F of xt1 and yt1. And we'll take the square to avoid the negative. And for each, you will continue and take the average of that. So that we will call it as the mean square error. So this is the mean square error, that there are m datas are there. So we will check the we will find the mean square error, and looking at the mean square error, we'll decide whether a linear algorithm is good for this data, linear regression is good for this data or not. Okay, so that is how the mean square error is the performance measure we have used. Yes, okay, so now I have explained one algorithm. Now there is this algorithm has a hyperparameter alpha. So how to choose the best alpha? and how to divide the data into, you'll be giving only a data in your hand, right? So how to divide the data into training and testing set, and how we have to do the validation, right? That is whether we have to test it only on one set of data, or whether we have to test it on more number of testing data, whether we have to validate thoroughly. If we have to validate thoroughly, how we are going to generate that testing and training data. So that is all we are going to do it by the cross validation. So, okay. So, so that is the next one. We are going to look at into how to generate the testing and the training data. So I'm going to explain two things, which is the holdout method and the k-fold cross validation. That is how to generate the testing and the training data. So first we will explain the holdout method. So first I'll start with this holdout method. So that is how to, you will be given a training data, you will be given a data in your hand, how to divide that into training and testing data. So, okay. So what we do is, first I'll explain holdout method. So what we do is, we randomly choose what we are going to do. You will be given a data and you think that let us use linear regression, but you don't know whether the function passing through is hyperplane or not. So we have to check whether this algorithm is good for this data, or should I have to move for other algorithm. We cannot, some data given for modeling, you will choose one linear regression and find W, and we cannot say that our work is over. We have to thoroughly validate the model. That is, we have to make sure that the algorithm we have chosen is best for the given data. So for that, we have to generate, we have to test it on different data sets. So how we are going to test it, or how we are going to divide the data into training and testing data from the given data. So, okay, so the first process is the holdout method. So in the holdout method, what we do is, we will choose 70% of the data for training. That is, randomly choose 70% of the data for training, and the remaining for testing, and the remaining 30% for testing. And then what we do is, we develop the model. That is, for example, if I have 100 data points in a hand, I'll randomly choose 70% as the training data and the remaining 30% as the testing data. And what I do is, using that 70%, I will find the W. For this linear regression case, I will find the W using that 70% of the data. And then I will check the performance. That is, I will, using that W, we will find, we'll be able to find what is f of x for the testing data, and I can find the mean square error. That is this one, mean square error. This is, there'll be 30% of the data for testing. I'll find the mean square error. So, okay, so I'll take the, this is the this is the model. Using the model developed, I find the value. This is the given value. I'll find the mean square error for the testing data. So, and we will repeat this and process 30 times, at least 30 times. So in statistics terms, something is greater than 30 is considered to be a large number. So we will repeat this 30 times. Repeating 30 times means in each iteration, we will randomly choose 70% for the training and the remaining 30% for the testing. And after selecting the training data, we will find the W if it is a linear regression, and using that W, we will test, we'll find the mean square error using the 30% testing data, and we will get the mean square error, and we will repeat this process at least 30 times. Okay, that is the number of iterations will be 30, and inside that iteration we will divide it into testing and training data, and using the training data we will find W, and with the help of the W we will find the mean square error for the testing data. So at the end of each iteration you will get a value for mean square error. So if you are repeating this process about 30 times, we will have 30 different mean square errors, so that we have validated the model using different testing sets, so that we have make sure that there is no bias, right? We have not used only good points for the testing as the testing points, so that that is why we are repeating it 30 times. So we are making sure that we have seen all the different types of data by this process. So from the whole population we are getting only a sample, so we have gone through all the characteristics of the population by this process. So at the end of this one you will get 30 different mean square errors if you are continuing this process for 30 times, right? 30 different mean square errors. Then what we do is we will take the average of all those 30 different values, and looking at that average we will decide whether it is a good or a bad model. If you're happy with your result, we will take the entire data together and develop a single model. So what is happening? That is, for example, if I want to fix the hyperparameter alpha, I don't know the best value, so I will think that it is between 0 and 1, and so for each value, that is, for first I choose alpha as 0.1, and then what I'll do, I will this alpha as 0.1, put alpha as 0.1, and then from the given data I will choose 70% as the training data, and I'll find W. Using this W, I'll find the mean square error for the 30%, and then I repeat this process 30 times, and for alpha is equals to 0.1, I get 30 different mean square errors, and I'll take the average of all those 30, and I will get one value of mean square error for alpha is equal to 0.1. I'll repeat alpha is equals to 0.2 to 0.1, and from that I will choose the best alpha, right? For the one which has got the minimum. So that will be my alpha, and by selecting the best alpha, you have to look at the mean square error. Are you happy with the mean square error you got for the best alpha? If you're happy, you will say that yes, the linear regression is going to work, so this algorithm is best for this data. If that result you are obtained, what will you do? You will take the entire data together, and with the chosen alpha you find W, and that is your model you are going to show to the real world, right? So before showing to the real world, you will thoroughly validate it, and using holdout method you have divided the data into training and testing. Okay, now another way of dividing the data into training and testing is k-fold cross-validation. Okay, so this what we do is we divide the data into k different folds. For example, if k is equals to 10, I will divide the data into 10 different folds, right? 10 mutually exclusive and exhaustive. Mutually exclusive means no two folds have the same data. Or if you take the intersection of those folds, it will be null set. And also if you take the union, that will be the entire data what we have chosen. So divide the data into like that, mutually exclusive and exhaustive folds. So if it is a 10-fold cross-validation, we divide that into 10 different folds. And what we do is the number of iterations will be 10 if it is case 10, and in each iteration
Ma'am,
yeah break.
Kindly forgive me to interrupt you, ma'am.
Yeah.
We are having one more session also, followed by this one.
Okay.
Uh,
Okay.
I'm really sorry to interrupt you, ma'am.
Okay. So it's over.
Ma'am, if you can finish it up in a few minutes, then that would be good, ma'am, because we have some questions also.
Okay. So
Yeah, ma'am.
what is the question?
Ma'am, should I read it out to you now?
Yeah.
Yeah. First question is, does the probability of the label is indicated for the regression output 0 to 1? That is the question.
Probability.
Shall I repeat the question, ma'am?
Yes.
Thus, the probability of the label is indicated for the regression output to be 0 to 1.
Is he asking is the label indicating the probability?
Yes, ma'am. That is what I understood from his question. This is her question. Dear attendee, you can also elaborate, explain the question a little more further so that it will be easy for our professor to address.
Okay, so this is not the probability. So, okay. Right? This is, for example, this is a regression data and this is the angular acceleration, right?
Yes, ma'am. Ma'am, if I'm not wrong, it should be something below, before equation where you denoted the gap between 0 to 1 in the regression model, regression output.
Oh, okay,
Does it
okay.
count?
That is the output can be from any number between 0 and 1. Just said that it can take any numbers between 0 and 1, but so it is continuous.
Yes.
Right? Okay.
Yeah.
Okay. Okay. So okay, that is what.
I believe I understood in that way. Attendee, if you are online, you can respond to that. You can ask, one of the volunteers can unmute you.
It varies. For this one, it is not that one, right? It is just if given angular position and velocity, what is its angular acceleration?
Yes, ma'am. Yes, ma'am. Ma'am, I don't think so. The participant is here. Maybe shall we move on to the next question, ma'am?
It's
It is how the step length is selected for a particular application. Is it a varying or a fixed one?
okay. We can make it fixed one, or we can make it to be varied. Okay. So I have, for this case, what I have explained is a fixed one. That is, for each, we fix it first, and that is same for all the iterations. But it can be varying. After each iteration, you can decrease the fix that alpha also.
Okay, ma'am. I hope your question has been answered. Ma'am, moving on to the next question. How to choose hyperparameter learning rate?
Okay, that is why what I have explained, right? That I have explained that holdout and k-fold cross validation, right? So for each by choosing each, first we think that this hyperparameter is coming from some interval. For example, if you think that this hyperparameter is coming from 0, 1, and we will divide that interval into some 0.1, 0.2, 0.1, and for each alpha, you find for each alpha you run this algorithm. Right? If you're using the holdout method, for each alpha, you run this algorithm 30 times, means in each, you divide that into training and testing data, and use that training data, you find W, and you test it on the testing data, and you will get 30 different values for the mean square error, and you will take the minimum of that, and for each alpha you will find one mean square error and repeat it for alpha is equal to 0.1, 0.2 and find the best alpha, right? That is what I have explained. To find the to check the performance of the model and to find the optimal hyperparameters, we will use the cross validation. One is the holdout method and the other one is the k-fold cross validation.
Okay, ma'am. Thank you so much, ma'am. Moving on to the next question. How to decide the value of alpha?
Okay, that is what we are going. We will explain it, right?
Yes.
For example, if it is a holdout method, I want to choose the best alpha, right? So I'll explain this as the question is repeated. So I want to choose the best alpha. So I think that my alpha is coming from 0 and 1. So I'll divide that 0 and 1 as 0.1, 0.2 to 0.1. Then first we'll choose this alpha is equal to 0.1. Okay, so that hyperparameter with alpha is equals to 0.1. Apply holdout method, right? Apply holdout method and find the mean square error for alpha is equal to 0.1. Then take 0.2 and then find the mean square error. Like that, continue till 1. Okay, and then among this one, which alpha makes the minimum mean square error, fix that as the optimal alpha.
Yes, ma'am.
So hope you understood.
Yes, ma'am. I'm able to understand it. Hope the participant also on the other end was able to understand this. Ma'am, the next question is difference between multi-class and regression problem.
Oh, okay. Because multi-regression problem means the y label or the y values coming from an infinite set, or it's not countable, right? For the classification, it is a finite set. For example, if it is the angular acceleration, it can take any real number, right? So it is a continuous. The y can take any real number means it is not a discrete one. For the multi-class problem, the values the y can take is countable. So that is a classification problem. The regression problem means y is the set from which y can take different values. That will be an infinite one. That's a continuous number, right? So multi-class problem means even if it is for example, k multi-class problem means y can take only k different values. That is not happening in a regression problem. It can be any real number, or it can it's a continuous. Its domain will be a continuous. It is not. It may, for example, it's an interval or a real number. Any value from the any real number. So that is not happening in the multi-class.
Yes, ma'am. Yes, ma'am. Dear participants, if you have any more questions, you can ask. Maybe one or two we can deal with right now. Ma'am, I don't think so. There are any more questions from the participants. Yeah.
Okay, so I think we have covered only very little, right? Okay. So, okay, I thought
I'm really sorry to interrupt you because of the time crunch we were having.
Okay, fine. Okay,
it is a very informative session.
Okay, fine. Okay, so yeah. So as I thought it's 3 hours, I think I have also gone very slowly. Okay, fine. Okay.
Over to you, Meera, please.
Okay. Thank you so much, ma'am, for spending your valuable time with us. And I hope the session will give us a clear idea about the basics of machine learning, the different types of learning, and its application. We would really like to appreciate your effort to make this section more informative by providing some examples and all. Once again, thank you so much, ma'am.
Thank you, ma'am.
Okay. Thank you very much. Okay, thank you for attending this talk. Thank you for inviting me. So hope you have got some picture about the machine learning, some basic ideas about the machine learning. As you know, it is a very fast developing field. Hope this section gives you some hint regarding this machine learning so that you could explore more in this field. Okay, all the very best. Okay.
Thank you, ma'am. Thank you,
Thank
ma'am.
Dear participants, the next session will start by 4:15 p.m. So kindly make your presence and polling will be after this session. So with that polling, you will be marked your attendance only when you click on to the comment section.
Okay, Grace, we can start the polling now. Subin, can you do the polling now itself?
Yes, sir.
Okay,
Yes, sir.
already he has given the link
You
to
can
polling.
mark your presence in polling by clicking on to the present button. Your time, the time given for you will be 3 minutes. Try to make sure that you are doing it within the 3 minutes time. This is for your attendance, followed by your certificate once the program is over.
Yes, per the ATAL norms, you should have 80% attendance. Okay, so for morning attendance, already we have the WebEx attendance, so don't worry about the today's morning session. So tomorrow onwards, we have like this polling will be counted for attendance purpose. Meanwhile, if you have any queries, you can discuss with us regarding the sessions, or be too long or too short, or even on the about the platform, the text, or even other than. Subin, please contact ma'am. The last 45 seconds for polling. So till now we have 44 responses out of 59 participants. So we'll consider this for attendance. So that is 24% of the today's participants. They are not given any comment whether it is attending or not, or present or not. So already it is, you can see in your right hand corner, there is an option called polling. You can click on that polling option, whether you can mark at plus like present or absent, or present or not hands. Okay, so 45 attendees given the response. Okay, so we'll continue with the next session. So you can take 2 or 3 minutes break because already we are running out of time. That's why we are following this tight schedule. Okay. Okay, that's morning session. We'll consider that. Okay. Good evening, ma'am. No, polling will be done for the, from tomorrow onwards, we'll be having polling after every sessions. Okay. Grace. Grace, are you there?
Shall we start, sir?
We can start. Already ma'am is there, waiting for us.
Okay, sir.
Good evening, ma'am. Good evening, ma'am.
Yeah, good evening. So, are you able to hear me?
Yes, ma'am.
Okay.
Okay, ma'am. Just a minute, ma'am. A formal introduction. Our volunteers will. Okay. Satyaprakash, start.
Yes, sir. Good evening, one and all present here. This moving forward towards the last session of first day of
I'm
this
hearing some
5 days.
disturbances there, I think. The voice is not coming clearly.
Now is it clear, ma'am?
Yeah.
Okay. Moving forward towards the last session of the first day of 5 days FTP program, we have our speaker for the final session, Professor Trapti Jain. Professor Trapti Jain. She is associate professor in Department of Electrical Engineering, IIT Indore. She has received her engineering degree in electrical engineering from Government Engineering College, Ujjain. She completed her PhD in electrical engineering from IIT Kanpur. Her area of interest in research includes synchrophasor applications in power systems, grid integration of renewable energy systems, and artificial intelligence applications to power systems, power quality, and smart grid. She has published more than 30 journals, 22 conference papers, 2 books, and 2 chapters. She was conferred with IETE Technomedia Award 2018 for Young Women in Engineering. Hereby, on behalf of Power and Engineering Group, NIT Calicut, I take the privilege to welcome Professor Trapti Jain for this session. Over to you, ma'am.
Yeah. Thank you, Mr. Satyaprakash.
Thank you.
Only thing is like, do I need to, I'm not getting the option to share the presentation.
Okay, now you can, bottom you can see the share option. The window bottom you can see mute, start video, and share.
Yeah, so share option is not coming. Okay, let me see. Open system preferences it is giving.
Mama, you can click on that share option.
No, but this share option I'm not able to see actually.
No, bottom corner, your window bottom, your screen bottom, you can see mute.
Yeah, mute and stop video. After that, usually I think it comes. Okay, because I take classes on WebEx only, so it comes after a stop video.
Okay,
but
now you already.
It is not. So it is not coming.
Just a minute. Now you can see, ma'am. Just check it once.
No, still it is not coming. Okay, WebEx events to record your computer screen so that you can share content in events. Okay, I think I need to open the system preferences. It is saying something. The apps below to record the contents of your screen. Okay, it is asking me to. No, it is asking me to quit this Cisco WebEx events.
No, now you can share, ma'am.
Are you able to see? Because I am not able to see that share option is still.
Okay, ma'am, just a minute. Ma'am, can you reconnect once again?
Okay. Yeah, I will reconnect.
Okay, ma'am. Now it's visible. Hello, ma'am. Now it's visible.
Yeah. Okay. So, good evening, everyone. I don't know how many sessions you have already attended since morning. I am going to, although this FTP is based on this artificial intelligence applications to power system, and I have made this presentation very general. Rather than showing you that in what areas I've worked in AI applications, especially ANN applications. So for determining various problems in power system. Okay, but rather than showing my work to you, I preferred for today that we will discuss like in which areas of power system it has been applied, and even after, but if you go through the research papers, you will notice that a lot of research papers have already been published in this area. Okay, you'll find every other person is working in AI applications in power system only. But if you see the utility side, you will not find that these applications have been applied in practical. Okay, one application I'll tell you where it is used, but the way we have proposed this AI applications to power system problems, it is not utilized in utilities due to certain limitations posed by this. Okay, but with the advancement in technologies, they have some promise which we can utilize in the future. So like we should start thinking about them in the new way. Okay, so it is a very general thing. So like it is, I planned this presentation. Yeah, so I planned this presentation in 4 parts. So basically, when we are going to discuss about artificial intelligence, so we'll first discuss what is artificial intelligence and what it does, how it does, all those things we'll discuss it. And then we will discuss about in which areas of power systems they can be applied. Okay. And after discussing those things, we'll see that what are the issues and challenges they pose so that we are not able to utilize them in practical. Means we are able to publish a lot of papers, but we are not able to utilize them in practice in the utilities. And with the technological advancements, what are the new applications which they are coming up, that where we can apply this AI. So these 4 parts I have divided my presentation. So let us begin with introduction to artificial intelligence. So before I get into the depth of the topic, it is better to understand that it is better to understand what is intelligence. So it depends like how do we, although this intelligence is a very subjective matter, okay, and we cannot define, but we can consider this intelligence as the ability to learn and understand, learn from experience. Like if you see the example, so like kids, we are teaching anything. Maybe we can train the kids for anything, but let us say the example that we are teaching them how to cook. Okay, so they will learn and understand. And if you teach a kid how to play the chess, we are talking about the kid only here because kids, like it is better if you want to understand the AI things, how they work, it is better to see how kids learn. So that gives I think better understanding that how kids, when they don't know anything, how they learn. So this is the same way like AI can be trained to learn. Okay. So like if we are teaching the kids or training the kids to play chess, so like more he plays, more he learns. So that is how he will learn from experience. So that also can be called as the intelligence. Once you tell something, or suppose someone has gained some knowledge, then he should be able to apply those knowledge to solve problems, to adapt to new situations. Because So we gather that knowledge, and whenever the conditions come, one should be able to apply those knowledge. Then you can say that, okay, you have learned really, okay, if you are able to apply the gained knowledge. And then other thing is like one should be able to make judgments or have opinions that are based on reason. So we usually learn many things and we combine those things, and based on that we form some opinions. So we humans, we are able to do all these kind of work, okay, but obviously it will the degree to which extent we are able to do these things will vary from human being to human being, okay. So but this can be considered as intelligence, okay. So based on this, we can decide, we can consider what is artificial intelligence, although there is no single definition for AI, okay. But because we understood that what is intelligence, so artificial intelligence can be considered as it is as simple as simulating intelligence in machines, okay, so that they can be made to do the tasks as done by humans. So like whatever tasks we are able to do, we expect the AI also to do the same kind of tasks. Okay. So here are the examples of AI. So we all know, I think we very well know these examples. Let us start with smart assistants. Now you must be using this, Hey Google, Siri, Alexa, Cortana, anything. So these smart assistants, they can interact with you with your voice, is it? They can interact with you with your voice. You simply need to tell something and they can help you in anything. Like you want to search something over the internet, you can ask them to search this thing on internet and they will come up with some answer. You can ask them to call somebody on your behalf, they will do this. Is it? Maybe you can ask sometimes to tell a joke also. People used to do this and they will do. So these are the examples of AI. Then we have these days, we have Robo Advisors also. So Robo Advisors, these are basically the digital platforms where they provide like algorithm driven automated financial advices, okay, so that you can plan your finances very well. So these robo advisors, they collect data from the clients, okay, and they collect like data like what is their financial situation, then what are their financial goals, in how much time they want to have return. So like this kind of data, they collect this through online survey, and based on this data provided by the client, they give you the suggestions and to invest where it is better to invest your assets. Okay. So we have actually these kind of robo advisors like 5paisa.com, ET Money, and we have like Funds India companies. So it has Money Mitra as robo advisor. So these things suggest you, they collect the data and then suggest you. Then another example is like spam filters on emails. You will see that many times this, you will some emails, they will directly go to the spam. So basically how it is decided, na? So they are scanning your messages and based on some wake word or some words they will identify, they will give some label to them that it may be having like a malicious content or something like that, and based on that they give you a warning signal also. Okay, so that sometimes if it is not in spam, but they will come up with some warning signal. It is like that. Now you have chatbots also for customer service, like for routine kind of things, is it? So you can ask if your question is like that, they are not able to find out, they will refer to some person. Otherwise, you can interact with this chatbot for your regular queries. In fact, like Vodafone Idea, they have launched WhatsApp chatbot, and I heard that Swiggy and Zomato also have started like taking this chatbot so that they can take the orders and deliver the food to customers quickly. Okay. Then there are like some social media monitoring tools which can monitor that whether there is some dangerous content posted or some false news is posted on the social media. So there are like lots of posts have been there, isn't? So it becomes very difficult for the human beings to identify this. So there we can use these algorithms. Okay. And another most common thing is these days, whenever you see like some videos on YouTube or some movies on Netflix, so all these things, like they collect your past data. They are analyzing your past data, and based on past data, they are giving you a recommendation. Like if you see Amazon also, you're based on your shopping things, like whatever you have shopped or whatever you are searching on their site, based on that they recommend certain products to you, isn't it? So all these things, they are the examples of AI. So basically all these things, they are based on data only. So AI is dealing with data. They are basically data driven approaches. Now, what are the types of AI? So they can be classified broadly as artificial narrow intelligence, artificial general intelligence, artificial super intelligence. So artificial narrow intelligence, it is the most common, and rather I should say only AI which is existing today, because this kind of AI, they are trained to do only a single problem or single, yeah, they are trained for a single kind of problem. Okay, so and they, because they are trained to work a specific job, they do really that very well. Okay, so like Siri and Alexa, all these are examples of these things. They are trained only for a particular job, so they come under this ANI. Okay. Then comes AGI. So AGI, it is actually only a theoretical concept till today. Okay, so it is only a theoretical concept, because this AGI expects that it's a computer, it should be as smart as human. Okay, so whatever tasks we are able to do, a single AGI should be able to perform all these things. Okay. So basically, if you understand how this can be achieved, this should be like thousands of ANI should be there, isn't? And they should work together in tandem to achieve a particular goal, like as we do as a human. So that kind of intelligence should be there. Then it is artificial general intelligence. Okay, so we are far away from this AGI. Okay. Then comes artificial super intelligence. So artificial super intelligence is like, it is, you can consider this as a science fiction. Okay, we see in the movies, like we have robots which can do exactly everything what we can do, and I think they surpass the human capabilities also, isn't? So that is like ASI. So but once AGI is achieved, ASI won't be far away, because the gap between the two is relatively narrow. Okay, so like these are the concepts, but only the existing one is ANI. We do not have AGI and ASI now. Now this AI has also been broadly classified as weak and strong AI based on their performance levels. Okay, so like if you consider this ANI, it will come in weak AI. Okay, but strong AI, so because this AGI and ASI can come under strong AI. So weak AI, why this artificial, this narrow intelligence? So why it is narrow intelligence? Because it is able to work any one single job, is it? So that is a narrow application with a limited scope. You can train that AI only for doing a single specific job. So that is a narrow application. But if you come to AI, strong AI, like as AGI and ASI, they are like wider application with a more vast scope, because you are expecting them to perform all the jobs which a human can perform. Okay, so weak AI, they are good at specific tasks, but strong AI possess incredible human level intelligence. And this weak AI, so they use supervised and unsupervised learning to process data. But a strong AI use clustering and association to process data. So examples of weak AI are Siri and Alexa, but a strong AI, they are advanced robotics. They come only under strong AI. Now, so where can AI be used? Like what kind of problems we can use the AI? So whenever you have a problem where you want to make a finite decision, there we can use AI. So given a current situation with known data, okay, it is given to you, and then you have to make some best decision. That time you can apply AI. So example is playing chess. So if an AI is playing chess, how will it work? So it will consider the past movement which have been taken place, and it has then the possible future moves. So out of considering that what moves have already been taken, and having that what are the possible future moves that can be taken, it will be able to determine the best move. Okay, so that is like we can use AI for that, and it has been done already. Another thing is we are providing AI a set of images, and we are asking AI to give you the images which have people in it. That can be done. Then, so this one, making a finite decision, this uses supervised learning. Okay. Then making a prediction or recommendation. So this is also something like making a decision, but what it does, how it does, it recognizes patterns, and then it calculates the probabilities to find trends. Okay, so if you give the pictures, a picture you are giving to AI, and then you are asking to classify physical objects in that picture. So that is like based on some patterns, it will give you the output. So basically this kind of thing, it uses unsupervised learning. Okay. Then comes reasoning. So reasoning means deciding something based on in a logical manner. So like we as a human, we have knowledge of different parts, and we connect them together. Based on this connections of this various instances of various knowledges in different fields, we can make certain decisions. Okay, so like that, this AI also can be made. So it is like I would like to say that sometimes what happens, it is not like various knowledge. Sometimes you take a decision which you don't know how you are reasoning. So some hidden language is there. Okay. Like you can compare similar kind of situations we have faced, and analyzing those situations, then you take some decisions. Okay, so like that it can also be made to take decisions. So the example of this one is Google Translate. So Google Translate, it is giving you the translation from one language to other language, but we don't know the intermediary. We don't know, as a human, we don't know the intermediary language. So it also basically, how does it work? It compares the documents, various documents, millions of documents it compares to find out what is the right translation. Okay, so based on that comparison only or similarities only, it is able to find out. But this is possible only when you have a large data set, and then you should have deep learning with you. Then only this thing is possible. Okay. So what are the advantages of AI? So advantages of AI are like reduction in, obviously we are prone to make mistakes, isn't? But algorithm, if you have made properly without doing mistake there, then so it will perform as it is always. Okay, if no mistake is committed in making the program, so it will not make the error. It is available 24/7. We can work only for 6 to 8 hours, maximum 10 hours. But AI is available 24/7 hours. So you can use like customer services. They are available 24/7 using Chatbot. Then it helps in repetitive work. So as a human, if we are asked to do something repetitively, we will get bored very easily. But your algorithm can do it repetitively, efficiently. Okay? Then like it provides digital assistance, like chatbots are there, they are providing you digital assistance. Obviously, this runs very fast, so it gives you the decision quickly because they've already trained this AI for those specific things. But as a human will take time, but they will not take. Then rational decision maker. So sometimes it happens that we need to take the decision in a logical and efficient manner, and we have to take that quickly also. But maybe our emotions sometimes may take over that. Okay, but if you consider AI, it will make decision rationally. It will not, no emotions can take over there. So that is the advantage. Then medical applications, lot of applications are coming in medical or healthcare system. So like disease diagnostics, you can use them. You can use them to find out at the earliest stages like metastatic cancer. Various types of cancers can be detected through this. And when the tumor is very small, so that time also it can help you to detect this. In fact, robo-assisted surgery are also taking place. And the last one is efficient communication. So if you remember, suppose there are two people and they speak different language. They don't understand each other's language. Maybe one is speaking English or you can say any Tamil, and other one is speaking Bengali and they don't understand. So earlier, like if you are communicating, you need a person who understands both the language, and then he is helping to he's becoming a mediator between the two so that they can talk. Okay, but now with the help of Google Translate, it is not needed, isn't it? So there we are using AI. You simply ask the Google Translate. You tell this, it will convert and tell the other person. So this is how these are the advantages of AI which we are seeing in different fields or say in daily life things. So now how AI works? There are various components of AI. Okay, so like it is machine learning. So machine learning is basically algorithms. It is the collection of machine learning is basically the collection of algorithms. So it performs, it learns hidden patterns in the data, and then it gives you the output without being programmed specifically for giving that output. So it is performing through learning the hidden patterns in the data. So neural network, it is a kind of machine learning algorithm. So it is it works in a way like as our mind works. So we have different neurons which are connected together through some synapses or weights, and then we are processing those means the connections between those neurons. They are used to work. So in neural network also you have different kind of neurons, different layers are there. Those neurons, they are interconnected with each other, and they process the data, and the data is processed multiple times through those layers so that this neural network is able to learn properly. Okay. Then comes deep learning. So deep learning, basically it is a huge neural network and multiple or very large number of processing units. Okay, multiple layers are there so that they are able to learn the complex patterns in large amount of data. So whenever a large amount of data is there and the relationship between them, obviously when the large data will be there, relationship will be mostly complex. So that time we should use deep learning. Then comes natural language processing. So natural language processing is like it is the like it needs to analyze, understand, and then generate natural language like which we speak. So that is the natural language processing. Because of this only this Google Translate was possible. Then comes cognitive computing. So cognitive computing is nothing but it's simply like human means performing the cognitive function of humans. Okay, as we understand, so here AI and deep learning, both cognitive computings are used to perform all the tasks which as a human we are able to perform. And then comes computer vision. So computer vision basically it relies on pattern recognition and deep learning to find out, like if you give them images or videos, so they understand, analyze these pictures and understand those pictures. Okay, so this is what computer vision. So here, like you must have seen that people usually, they interchange these things, artificial intelligence, or you call them machine learning, or you call them deep learning. Okay, but they are different. Different in the sense, AI is the whole field. Okay, so it is the programs with the ability to learn and reason like humans. So all those programs come in AI. Okay, but machine learning, it is a subset of AI. So algorithms with the ability to learn without being explicitly programmed, they are all machine learning. So you can say that ANN basically, it is a subset of machine learning. And then deep learning, so it is a subset of machine learning in which artificial neural networks adapt and learn from vast amounts of data. Okay, so and now let us see machine learning, because I thought that it is very important to understand what kind of learning, basic learning techniques are there. So they are supervised learning, unsupervised learning, and reinforcement learning. So in supervised learning, what happens? This algorithm learns the relationship between specific inputs and outputs based on training data and human feedback. So basically, human feedback means you are providing training data set, it contains of input and the desirable output. So supervised learning, basically the training data set will comprise of inputs and outputs. This together will make training data. So you are already providing them output. So then it is known as supervised learning. Okay, and it can be used in regression and classification kind of works. Then comes unsupervised learning. So in unsupervised learning, this algorithm analyzes the data for trends and patterns without being given a specific output variable or human feedback. So the output you don't know. You are simply giving an input data, but you don't know the output. So basically here they are trying to understand the pattern, or they are trying to find some similarity or differences between the data. Okay. So it can be used, it is used for clustering and dimensional reduction. And then comes the reinforcement learning. So the algorithm learns over time to maximize returns based on the rewards it receives for performing certain actions. We'll see this later. I have made one slide for this reinforcement learning also, so I'll explain it there. So this can be of two types, model free and model based. So like this is the example of supervised learning. So we are giving input data and labels also that these are apples. These are given as inputs to model, and then it is predicting that it's an apple. But in unsupervised learning, what is happening? These fruits are given and no output is given to the model, and it is finding similarities. So it has, based on this similarity, it has given this, that it can be one cluster, it can be second, it can be, so three categories we have obtained. So classification, what is the difference between classification? What is the difference between clustering and regression? So in classification, what happens? You have distinct groups of data that exist, and new data elements should be classified into these existing groups. So like you have here, these two classes are already there. Now when you are giving this one, so it should be able to identify whether it will go to this one or it will go to this one. And in clustering, no groups of data exist initially, but one creates groups from the data close to each other. So usually this is performed on the basis of the similarities identified using some distance measure. So based on that distance measure, you can calculate that this group of data will come in this cluster and the other group of data will come in this cluster. So these are close to each other as compared to the distance between them. So this is how this is formed. Then in regression methods, the idea is to identify this line with a certain slope that is able to describe the data. So like here we are not here, this, for this one it is this slope, but it is like a line. Okay, so this is the regression problem. Now dimensionality reduction. So as I told you that this unsupervised learning can be used for clustering and dimensionality reduction. So even if you are using clustering, you can take one representative variable from each cluster and that can be So like earlier you have 20 data points, you have 20 inputs, and now suppose you say that this 20 data points have been clustered into 3 clusters. Okay. So then from 20, so from each cluster you can take one data point as a representative one, and then that, so rather than taking 20 inputs, you can take only 3 inputs. Okay, so this is how dimensionality reduction can be performed using clustering also. And the other way to reduce the dimensionality is to transfer high dimensional data into efficient low dimensional representations by finding appropriate transformations. So you have certain data and then you're transforming it into low dimensional, like usually principal component analysis. It transforms high dimensional data into low dimension, and then you take those inputs as the features. So now this is reinforcement learning. So basically reinforcement learning is all about taking actions to maximize rewards. So what will happen here, that this input is given to the model. So there will be an agent, which is basically a program. So it will take certain action. Okay, it will take action. So it will work interactively with this environment, and this action is given here. And based on the feedback, it will be either rewarded or punished. Based means whatever is its action. So based on that action, it will be either rewarded or punished. And then it will do this multiple times. It will learn through experience that what is the best action to be performed, and then it produces output. So like you can see, this is the easiest example. We are giving this as an input. So we have not given any output here. Its response is that it's a mango. Then we gave them feedback that wrong, it's an apple. So now we have told the correct response. So now it has learned that, okay, note it, and then when you give this next time, you will get the reinforced response. Okay. Now reinforcement learning, so it can be of 2 types, model-based and model-free reinforcement learning. So model-based uses a previously learned model to accomplish the task, whereas model-free relies on some trial and error experience for action selection. So like you can consider this as taken from this reference paper, and so suppose a person has to go back to home from work, okay, on Friday evening. So like model based, he is having map with him, so he can follow that map itself to reach the home. This map he must have learned through experience. That is also possible, or otherwise he had been provided the map. So that is the model based. Other thing is, like from the past experience, when he visited home from work on Friday evening, so previous experiences told him that don't take freeway, rather go straight. So that is like model free. There was no model, but his own experience told him. So these kind of models exist for reinforcement learning. So this is the general introduction about the artificial intelligence. Now we'll see how they can be applied in power systems. So before we go at how they can be applied to power systems, basically we should see why they are needed in power systems. So we know our power systems, they are with time, they are becoming more and more complex with addition of more elements, complicated elements in its structure. So they are complex in structure, and whatever components you are adding, like fax devices, power system stabilizer, generators, turbines, and transmission lines, distribution lines, everything. Like if you consider these components, so if you are doing any analysis on it, you need to model them mathematically, and those mathematical models are complex models. The behavior of power system is highly non-linear. Okay? So this is the thing, and now when you are performing any analysis, if you use the conventional methods, they are very time consuming. So the conventional methods require mathematical models, and it is difficult and because the relationship is non-linear, it is difficult to solve those problems also. Okay, they are very time taking. And another point is, whatever analysis you are doing in power system, they need to be performed quite often, from few minutes to few hours. Few analysis you need to perform every few minutes, some like every few hours, like that. So and the practical power system, if you consider, they are very large in size also. So all these methods, they are very time consuming. So based on that, and their accuracy also depends upon the model you have taken. So considering these features, it was thought that because AI, it deals only with data. It doesn't see what is the model. It doesn't require that. It needs only the data. So it is the data-driven method which is capable to model any degree of non-linearity. And it doesn't require any knowledge of system model also. So this is the main advantage where we can use. And another thing is, once they have been trained to do certain tasks, they give you answer also very quickly. So they have this learning ability and fast response. So our requirement, our problems in the power system, they are like matched by the solution provided by AI. So due to this, we can use, there exists some opportunity that we can use AI in power systems. So now, for what kind of power system problems this AI will be suitable? So for forecasting problems, because there is no analytical model existed during, like if you use the statistical methods, they may not be that accurate. They're not that accurate actually. So for forecasting kind of problems, AI are very useful. And in fact, this is the problem where they have been used. Okay, they are being used for this kind of thing. So load forecasting, it is very uncertain, various uncertainties are associated with this load forecasting. So there it is better to use AI because they will simply identify the hidden patterns in the past load data, which we are not able to capture. So there it is useful. Then comes price forecasting with the deregulation of electricity markets. Like price forecasting is another area which has come. So price forecasting, so because this price, if you see the electricity price, how it varies. See, it is it has having high frequency, non-stationary nature, and highly volatile because it goes to very sudden large or low price spikes. So this kind of thing, it is very difficult to handle with the conventional statistical techniques. So their AIs are very useful. Okay. And by generation, I mean renewable generation. So like you want to carry out like solar power forecast or wind speed forecast. So for these kind of things, these AIs are very useful, and they are used also. Then comes economic load dispatch. So for economic load dispatch, like we are allocating generations to the already committed units, such that your operating cost is minimized and they are subjected to certain operational constraints. So this problem is a non-convex optimization problem. So if you solve it, and this also it needs to be performed quite frequently in the centers. So it like the solution, basically if you use, because it is a non-convex optimization problem, if you use conventional techniques to solve this problem, you will not get the optimal answer. Okay, so basically different techniques have been proposed, like this PSO, GA, all these kinds. They also fall under this AI, but I would rather say that they are not that fast. This PSO and all these things, they give you near optimal solution for this kind of problems, but they are not that fast. So maybe if you have sufficient data for that, then you can use another AI techniques which are quite fast to give you the solution. Okay. Then security assessment. So this security assessment, it needs to be carried out quite frequently, that is every few minutes, to check whether your system, because operating conditions is changing continuously in power system. So for every change in operating state, you should carry out the security assessment, that whether the system is secure under this condition if some contingency happens. Isn't this is what security assessment. So if practical power system you consider, it comprises of thousands of buses and thousands of lines. So carrying out the security assessment quite fast is not that easy. Isn't? So there this AI finds an opportunity. So if you are able to have that much data and you can train that AI, but only thing is you should cover all the possible conditions. Okay. Again, transient stability assessment. So to analyze this transient stability, you need to solve differential and algebraic nonlinear equations, which itself will take time. Okay. So here it finds the solution that it can be used. AI can be used to assess the transient stability quickly. Then fault diagnosis. So fault diagnosis, so basically here you want to identify the faulty part of the component, where the fault has occurred, which part is faulty, isn't? So based on certain data. So if we are doing it by conventional method or analyzing it ourselves, it will take time. So there AI can be used. Further, AIs have also been applied for fault detection and localization also. That what kind of fault has occurred, which lines it has occurred, and what is the location. So for that part also AIs have been used. Okay, many papers have been published, but they are not used like in utilities. Then comes power system control. In power system control, we are using different kinds of controllers. Okay, and we have to set the tuning parameters for these controllers. Like suppose if you consider power system stabilizer. Okay, so you have to set the parameters. You have to tune the parameters. Now, when you are doing it using conventional techniques, so how do? We linearize it around. We linearize around the non-linear operating point. So we linearize and then we obtain for a particular state the tuning parameter. But you see, as soon as the operating condition changes, that tuning parameter may not be sufficient. So how do you achieve this? So the tuning parameter should be such that it is able to achieve the desired control over a wide variety of operating conditions. So there we use AI to tune the parameters. Then comes power quality monitoring. So like various kind of disturbances, power quality disturbances are happening, and you have the data with you. So how to analyze, because that is a huge data, and how do you analyze, because those waveforms, they are non-stationary in nature. So you apply basically some digital signal processing tools to get some information from those signals, and then to classify that what kind of power quality problem has occurred, you use AI techniques. Okay. Then available transfer capability determination. So this is basically the additional amount of power that can be transferred over the network, considering the various uncertainties, generation uncertainty, transmission uncertainty, and above and all over the existing commitments. So, and this information you have to post over the internet. Okay. So it also needs to be updated every 5 minutes. So there you need, and obviously when it is a kind of security assessment which we are performing in deregulated environment. Okay, so it also needs to be performed quite frequently, and while determining this, you need to consider all the possible contingencies, all the transactions also you need to take into account. So this is also a time-consuming task. So there AI can be used. And then congestion management. So congestion management is basically overloading of lines or transformers, and many optimization-based methods have been proposed, but to solve them it will take time. It takes time to. But all these problems, they need to be dealt every time, means most frequently, or you need to solve these kind of complicated problems in real time. Okay, so using the conventional methods, it takes time. So we see that AI, if trained properly, it finds an opportunity here, and it has been applied. I will say it has been applied to many problems in research papers. So now because I've worked on ANN rather than taking an AI, although these are the common things. So we'll consider ANN based solution approach. So suppose we are applying ANN to this, any of these problems, what are the general steps? Okay, how can you apply? So first thing, because they are the data driven approaches, you need to generate a database, and a huge database is required, which should be able to cover all the possible loading scenarios, all the possible contingencies if you are doing it for security assessment. So a huge database you need to generate. So that is the first step when you are going for the NN based solution approach. So, and then this database, it will be divided into two parts. One will be training and other will be testing. Okay. So, and see, the larger is the size of database, there is a chances that your ANN will be trained quite well. Okay. So that is the first thing. Once you have generated the database, then you need to identify that what variables you will provide as an input to the ANN, because there are, if you consider practical systems, thousands of variables will be available, but you cannot use all of them, isn't? Because the number of inputs, once you decide the number of inputs, that will be the number of neurons in your artificial neural network, input neurons in your ANN, isn't? So you need to have fewer inputs. So you need to identify that which inputs are important. Means they should not be irrelevant or redundant inputs. They should be selected such that your neural network is able to map the input with output efficiently. So you should choose certain feature selection technique. There exist many feature selection techniques. Okay. So out of that, then again, you need, this is trial and error approach. Okay. You need to select certain and then see the performance of this neural network, how they are performing with this input features. So that is the second task. Once you decide that what are all the inputs you are going to use, then comes pre-processing of data. Pre-processing, why it is needed? Because see, your inputs, they will be varying in nature. Some inputs will be having quite large value. Some inputs will be having a very low value. Maybe suppose if you are using power flow, then obviously we'll use in per unit, it may be very large, or the power generation, it may be very large, but voltage values if you are using, it will be very, because it will be within 1 unit, 1 per unit. So this difference, so what will happen, the higher valued inputs will suppress the influence of lower valued inputs. Okay. So for this reason, we need to pre-process the data. So pre-processing means you need to normalize the data. You bring the data within a given range. Like maybe you can decide +1 and -1. The data should fall within this range only. So some range you should decide and bring all the data into that range. So that the mapping becomes easy. Once you have pre-processed, then you have to decide architecture of NN. Architecture means inputs, number of inputs are decided, number of outputs you already know. So like how many hidden layers should be there, how many neurons should be there in each hidden layer. So like this, so if you consider it is like trial and error, and you have infinite options, isn't? Until you achieve the acceptable performance. So that also needs to be decided by trial and error only. And once you decide that this is structure, and it will be, I think, in a iterative way, that once you take certain architecture and you choose one algorithm, so then you have to decide training algorithm and parameters. So once you have taken one architecture of neural network, then you are selecting some algorithm, you are applying that algorithm, you are selecting the parameters like learning rate and momentum. So these things are selected, and then you are testing the performance of that N. And if you are not satisfied, change the architecture, change the training algorithm. So this will go hand in hand. Then so you have to find out the balance between these. And once you have trained, then performance evaluation. So performance evaluation comes that when performance evaluation is basically during the training, your ANN is performing very well. But when you are giving it unseen patterns or unseen data, then how it is performing. Because this is how it is going to perform in practice. So that is the performance evaluation. So all these steps are needed if you are solving certain problem with or using ANN. So now let us see, so many research papers have already published based on this area, but still they have not been utilized in practice. So what are the reasons? So the first reason is scalability. So see, when you are testing your data, you don't directly go to the real-time power system. You take certain benchmark system, you develop, you test whether this inputs and that approach is going to work or not, and based on that, you will plan for real power system. So the ability to scale ANN applications to realistic dimensions for power system problems is a major issue, because as the size increases, the complexity of the neural network also will be increased. Okay. Then selection of input features. So the realistic power systems have potentially tens of thousands of input at the system level, and out of this great number of inputs, how to decide? So your whatever method you are choosing for identifying the input features, that should be chosen very judiciously, okay, so that it works. So actually, see, it is all hit and trial. There is no specific guidelines to use that which one will work. So that creates a certain doubt that maybe it is able, because it will depend upon the characteristic of the system also. Then size of training set. So you should have large training set containing all the possible loading levels and topologies of the system is required to obtain sufficient accuracy. So you have, if you want to get sufficient accuracy, then your training set should be large. And as far as possible, all the possible situations or loading scenarios should be considered. All the possible topologies should be considered, because anything for which it has not been trained, it will not be able to give you the correct answer. Then size of ANN. So this dimension of the architecture space is infinite, since the number of neurons and nodal connections is unbounded. It is the practical power system. So how do you define? You cannot go again and again to find out the trial and error. Let us say that we determine certain architecture also by trial and error, but there will be many things which will be continuously changing. So you have a doubt whether that neural network will be able to perform or not. Then the long training time. So training time increases non-linearly with problem size, and you have to train the neural network offline. And then characteristic of training set. So if the training set contains input patterns with different characteristics, then training of a single NN could be difficult, which is quite possible for a practical power system. Now, the characteristics will be quite different. So in that case, what you can do, because if you are doing relatively minor modifications also, it is quite possible that your NN may not give you the acceptable result. So then you, if this case exists, then you can have different kind of neural networks. But managing a large number of neural networks also will be a challenging issue. So then reliability and accuracy. So ANNs are unable to accommodate relatively minor deviations in power system operating conditions and topology. So like this will obviously be there, and if they are not able to accommodate that, it means they will not be able to perform to your acceptable conditions, and they are found to be sensitive to topology changes leading to inaccurate results. So you should be able to cover all the possible topology changes. Okay, if you miss some, then it may not give you, or it may give unacceptable results. Okay, and this is like updating the database. So because if you consider the practical power systems, the conditions are changing frequently, and you will observe different kind of conditions which you are not able to simulate in a software. So once those kind of conditions are there, you need to update your training database, and once you update the training database, then you need to retrain your network. So these are the major problems from practical perspective. So we have not deployed the AI techniques there, but we use it in forecasting techniques, okay, not for the other problems I mentioned. So we are not using it there. major problem is like data generation. We don't have accurate data also there. So considering this, now let us have a look, which is, I think, which will be more interesting to see that how the new applications are emerging, of these AI applications are emerging. So before we see how new applications are emerging, it is better to see why they are emerging. Okay, they are emerging because we have now improved measurement infrastructure. So if you consider the distribution side, widespread installation of smart meters and sensors enable the availability of large data volume, which you were not having earlier. So a large amount of data is now available to you, which can be analyzed and which can be used to train AI. Okay. And then in the transmission side, if you see, we are increasingly deploying phasor measurement units, which provide aligned data in real time from multiple remote locations across the grid. I hope you must be aware about this phasor measurement unit. So they provide you the voltage phasors and current phasors. So, and from different locations, so their time is stamped and the frequency is also quite high. The reporting rate can be from 25 to 50 hertz, 10 to 50 hertz. So reporting rate is also very high. So they are giving a large amount of data. So earlier, if you see, we were having problems in data only, but now we have real-time data. A lot of big data is available with us. So that big data can be used in AI applications. Okay. So this is the maintenance facilitated by image processing. So this is very interesting application. So the United Kingdom's national grid, they are using drones to monitor wires and pylons which are transmitting electricity to homes and consumers. Okay. And so these drones, they are equipped with high resolution still and infrared cameras, and they are capturing the pictures. Okay. So they take these pictures, and the advantage of drones are they can cover a vast geographical area and they can go to difficult terrains also. Okay. So they are capturing the images of different components, and those images, they are analyzed to see whether certain like insulators, so they are having some problem, we need to replace those insulators or we need to repair those insulators. So these kind of things are being done. They have been used to cover 7,200 miles of overhead lines across England and Wales. Okay. So they are having these images, and AI is then used to monitor the conditions of power assets and to determine when they need to be replaced or repaired. Okay. So this is, I found this is very interesting application of AI, and rather like apart from this, I've also read that EPRI is also carrying out few projects where they are considering this only. So, but if you consider, only thing is like we will have less number of images to apply this AI efficiently. The database required is quite large. Okay, so if you see like Google and all this Facebook, they are giving they are using this AI. So there they are using millions of data sets. Okay, whatever data they require, it is in million numbers. Okay? But we cannot have that kind of data set. That is the problem in this power. Then comes energy efficiency decision making. So like you all know that this smart devices, they enable customers to interact with their thermostats and other control systems to monitor their energy consumption. Okay. And so like these devices, when you can interact to monitor energy consumption, they will control the things. And the digital transformation of home energy management and consumer appliances will allow smart meters to use AI to optimize energy consumption and storage. How? Suppose the price is high, so they will switch off they can ask you to switch off certain appliances. If price is low, they can tell you that this time the electricity can be stored via cars or some other storage means, or maybe you can use the solar energy this time. So this kind of information can be received because we are not able to monitor each and everything ourselves. So they can be used there. Then selection of energy providers. So like as we considered the example of Robo Advisor in US, where the customers have this privilege of selecting their energy providers in those countries. So we can use this kind of AI. So here AI empowers consumers to determine their energy provider based on their preferences of energy source, their household budget, and their consumption pattern. Okay, so they can tell this, that which energy provider they should select. In fact, the researchers at Carnegie Mellon University, they have developed a machine learning system which is called Lumeter. It combines the customer's preferences and consumption data with information on the different tariff plans, limited time promotional rates, and other product offers. So, and then based on that, it provides recommendations for the most suitable electricity supply deals. It is similar kind of like Robo Advisor. Then theft detection. So AI could be used to spot discrepancies in usage patterns, payment history, and other consumer data in order to detect electricity theft, because now you are using smart meters. And many papers have also been published in this area. So you are using a smart meter data, and then you are analyzing those data to identify discrepancies in usage patterns. And there you can find out which household is using this is abnormal usage is observed. Okay. Then the University of Luxembourg has developed an algorithm that analyzes information from electricity meters to detect abnormal usage. So these kind of applications have emerged. This there must be many, but I have included only these few applications. So here I would like to conclude that with the technological advancements in measurement techniques, there exists enough opportunities for utilizing the potential of AI in power systems, because now we have data available with us. If you consider that aspect, that data is available, so you don't need to generate a database. That data itself should be utilized. Okay, that data itself should be utilized to use AI. Okay, AI techniques. So you don't need to generate the database. That database itself should be analyzed. But the problem is how to acquire, if you are an academician, how to acquire that data. That will be a problem. It cannot be given like that. So there exists that this data is available, but how to acquire the data to carry out this thing. So maybe utilities have to find out certain way so that this can be carried out. Okay. So I would like to end here, and now we are open to question answer. I think I'm on time. Shall I stop sharing?
Grace?
Yes, sir. Yes, sir. I'm just connecting my audio, sir. There is a problem with my audio. Just give me a second, sir. Thank you so much for your lecture, ma'am. Shall we move on to the question session, ma'am?
Yeah, sure.
I could find a few questions on the chat box. I'll start with the first question now. Is it possible to predict power quality of signals? If so, how? Input data can be formulated in a predictive way other than typical classification problem.
Can I see the question? Like it is
yes,
not written in my.
I'll post it in the common chat box.
So
can you able to see that, ma'am?
No.
Okay, ma'am. I'll.
Yeah. Now I can see it. So is it possible to predict power quality of signals? Yeah, it is possible. How data can be formulated in a predictive way? See, basically, what happens when you are monitoring power quality? So you are acquiring signal, and first before you go to apply AI, you should be able to apply signal processing. So once you receive the signal, then first signal processing is required. Okay. So by processing the signal, you extract few features which you have found that it will be useful. Okay. While developing your AI, you will find that this feature is useful. So you first, the most important thing there is, before application of AI, is signal processing. So you should apply signal processing, and then you will train your AI based on those signals, which features which you have extracted by signal processing. Those features will be used to train the AI to classify what kind of power quality disturbances have taken place. Okay, is it okay?
Yes, ma'am. I believe the participant might be satisfied with this answer. You can respond on the chat box. And
No. Okay. So, like Dr. Deepak is asking, any open data set is available? No, I am not aware of. Like whatever we have done, we have simulated and we have taken. I think this on hardware also. We have acquired the signals on hardware. But you can collect the data, like wherever power quality analyzers have been installed. You need to talk to them to get the data. So from there you can get the data. Okay.
Okay, ma'am.
So second question I can see, I think I missed before this. No? The second question is, what are the different feature extraction techniques for power system applications? See, there is like one which is very commonly used is principal component analysis, then independent component analysis. So there are many, but I remember principal component analysis only because there is a difference between feature selection and feature extraction. Feature extraction basically are called when you are reducing the dimensions of transforming your feature space into low dimensional space. There you are saying feature extraction. Okay, I am aware of, like, right now I remember only principal component analysis and independent component analysis. I'm sure there must be other methods as well. So that you need to decide yourself that what method will be best.
Yes, ma'am. Thank you so much, ma'am.
Yeah.
There is another question.
How to decide the optimum reactive power setting of the converters while keeping the OLTC tap control into consideration? Which AI techniques?
I'm not able to see that question, ma'am.
Okay, I don't know. I think yeah. So how to decide the optimum reactive power setting of the converters while keeping the OLTC tap control into consideration, and which AI techniques? See, I'm not aware of this problem. Okay, so I cannot guide you on how to decide this optimal reactive power setting. Okay, so this I won't be able to tell you, but like which AI technique would be feasible and how to achieve this. This is what I was telling you in issues and challenges. Listen, so you cannot decide. First thing, whenever you are selecting any particular AI technique, so you first need to understand what is your problem, what is the nature of your problem. Based on that, you should try to match those characteristics with the AI characteristic. And then you can select. So it is not like whatever method you will select, it will be able to perform well. But you need to do trial and error. Listen, you need to select one method, then you try for some other method. So it takes time. When the results come, it appears like it's quite fast, but while preparing the model, it takes time. It is really, you need to invest your time.
Okay, ma'am. Ma'am, were you able to see the third question?
No, after that, I'm not able to see.
Okay, ma'am. I'll read out the question for you. Normally, AI is prone to biases. Can such biases affect power system applications also?
Your voice is not clear. Can you make it that I read, because that helps me actually. If I'm reading the question, it is helping me.
Okay, ma'am. I'll do one thing, ma'am. I am submitting it to you right now.
Okay.
Can you see the question now, ma'am?
Yeah. So I don't think that these biases affect power system applications. Applications it will not affect. Obviously, performance for a particular application it can affect. Okay. Then
Participants, if you have questions.
Okay. My research work. So see, in AI application, obviously I think you must be wanting to see my research work in AI application also. Only AI application, na?
Yes.
Okay. So you can go through like my this web page, and there you will find few applications. I have done this for security assessment. We have used radial basis function neural network for voltage contingency analysis. Then I've used for available transfer capability determination. I have used, and we have worked with one of my students on power quality monitoring. Also, we have used this AI techniques, and we are like right now I'm working on data analytics. Okay, so we are using like phasor measurement units data, and then we are analyzing those data to solve some specific problems. Okay, so I think more detail. I don't know whether it was, I would like to know actually from audience that whether they find this thing useful or not. The reason is, I thought that if I present my research work, you may not be able to learn that much. So rather than giving specific research work to you, because then you will be able to understand only one problem. So I thought that rather than giving you that, I should be giving you try to give you broad exposure so that you can select the problem of your choice, but you have some idea how to use AI there. So this input, this feedback I would like to have from the audience, so that I have this, that if in future I'm giving talk somewhere, whether I should give specifically like my research work, or I should give them this opportunity that they means a broad exposure to that area. Can audience give me this feedback?
Participants, I hope you heard the question from ma'am. It would be better if you can write your responses in the chat box. Ma'am, I have a question on this artificial intelligence and machine learning techniques, ma'am. Basically, ma'am, am I audible?
Yeah.
Yes, ma'am. So I basically work towards the stability analysis of a power system. Say one is the conventional system and another one is a microgrid based, renewable energy based microgrid systems. So is it suitable to replicate the control systems, say model predictive control and other things in the same artificial intelligence area? Because
actually, see, it is not very clear your voice, na. Some disturbance also is coming. So
sorry, ma'am.
That is the reason I'm not able to hear properly. So
okay. Ma'am, can you able to hear now?
Yeah.
Yeah, yes, ma'am. So I'm basically working towards stability issues in power systems.
Okay. Yeah.
I'm considering the conventional system as well the microgrids, which is integrated with the renewables.
Yeah.
Okay. My question is, ma'am, so far, the stability analysis techniques are based on the model predictive control, or say control systems will come into the picture. Is there any way we can include artificial intelligence and machine learning, deep learning techniques for analyzing the stability of a system and working towards the improvisation?
See, you can do that, but the thing is, like, what I feel like, if you want to do it in microgrid, is it?
Yes, ma'am. One is microgrid, and the one is
So see, this has been done. This specifically in conventional power system, it has been done. Okay, but the problem is, this is what I told that. Okay, so problem is that, like, you need to generate the database now, and that database may not be matching the exact characteristic of the system, isn't it?
Yes, ma'am.
In real system, if you compare, so that is the problem. Only thing is, you can apply that there in microgrid as well as in conventional power system. Okay.
Yes, ma'am. So, what I understood from your answer is if we have the perfect or accurate predicted data, say forecasted data, then we can easily use artificial intelligence technique, isn't it, ma'am?
So it will be better because my experience tells this. That is the reason actually we are not able to utilize, isn't?
That's right, ma'am.
So many research papers have been already published in this area, but we are not utilizing them on utilities. Isn't?
Yes, ma'am.
So then what
Yes,
is the
ma'am.
use of publishing so many papers?
That's right, ma'am. That is right, ma'am.
Isn't? So that is the, in fact, recently on Power Globe, a thread was there that some people want to know that whether we are using this AI techniques in reality. So nobody could come in that with the utilities are using it, isn't? Because there are certain problems. Okay.
Yes, ma'am. Yes, ma'am.
So that is the thing. So this is what, Miss, from my own experience, I thought that there is no point in working in that way, like the way we used to work previously. But now we should use use AI for big data problem. Whenever data is available, it should not be like data you need to generate. If data is available and practical data, you are able to acquire that data, then you should work directly on those data because it will be matching with the real characteristic. Okay.
Yes, ma'am. Yes, ma'am. Because I have seen one of the papers where they worked for pricing, economic pricing for a particular building or of a particular community. They used forecasting techniques with the background of artificial intelligence, and they were able to calculate the economical cost for a particular time when the power supply is on. But I could very rarely see things which has been implemented in the area of stability studies, especially low frequency oscillations.
Yeah, this is what I told you.
Yeah.
Okay.
Yes, ma'am. That's what my doubt was, ma'am. And also, ma'am, there is a response from one of the participants. I'll read it out for you. It would be nice if you could include your research work in a concise manner towards the end of the seminar on your future seminars.
Yeah, so I would like to say thank you to this participant.
Mr. Roshan has pressed.
So thank you, Mr. Roshan. I'll definitely take this, I'll consider this in my future things.
Yes, ma'am. Excuse me, ma'am. Myself, Rahul. From ATC. I have go through some of your papers, ma'am, on subspace modifications or something, which was the Joyce film. I have doubt in this session, ma'am. Some pre-processing part. Actually, the pre-processing part is included in some signal processing algorithms and also some machine learning data processing itself. But there are different pre-processing stages in many others and many papers as I suggested in different manner. So what are the pre-processing stage? What are the steps we should include in that pre-processing stage?
See, pre-processing is only that, as I told you, it is normalization. See, features, some people consider processing of data like feature selection and feature extraction also, they consider it as a processing of data. Okay, but I've considered like feature selection different, feature this dimensionality reduction, so that is the feature selection, and then pre-processing. Once you have decided, so you are basically bringing the data rather than having a wide range over which the data values vary. We are compressing them to some suitable range.
Yeah, some others are normally doing some mean x-mean value and take it as a mean average.
So actually, this is what depending upon the problem which they are solving. Based on that, they can decide. But there are for every case, whatever I have told you, the steps of this ANN-based solution approach, there will be different methods. So that nobody can tell you that which specific method you should use. Okay. So there you need to analyze your data also, and some particular technique will be able to work. I cannot tell you that this method will work on every problem.
Yeah, that's different are applied by different authors. There only downsampling and
so this is what, these are huge things are there. but then how to come to some conclusion, that will take some time. There is no guidelines that you can use. So you have to, means some technique can work on some specific data, but that will not be able to work on other data.
Yeah.
Okay.
Okay, ma'am. Extreme pleasure to meet you. Okay, thank you.
Okay. Yeah.
Thank you, ma'am, for a wonderful.
Yeah. So,
Okay.
okay, sir.
Satyaprakash?
Meera, could you deliver the vote of thanks?
Thank you so much, ma'am, for spending your time with us. And it was really a great section. I believe this session gives a very good picture about artificial intelligence and its application to power system. We are really enlightened with your knowledge and presence. And I hope this session will help the participants for improving their future reference work, research works. Once again, thank you so much, ma'am.
Okay, thank you so much.
Thank you, ma'am. Thank you. I'll contact you soon.
Thank you.
Okay, ma'am.
Yeah, sure. Okay.